later. Okay, I think now we have enough participants. So, okay, so let me start sharing my screen and let me know once you can give me a second. Settings as well. So can you please make me host if there is anyone from Geeks for Geeks? I don't have permission to share my screen. Okay, thanks. So let me. Okay, so I hope you guys can see me now, and let me also share my screen. Okay, all good, right? So guys, this is a repository which we have created in our last class. This is a day number 2 for GFG workshop. Overall, we will have 3 sessions. Okay. In the first session, we have discussed about CI/CD pipeline. We have discussed about DevOps. What is DevOps? Why companies are using DevOps, and why do we have so much demand of DevOps? And those people who are expert in DevOps, why they are in so much demand? We discussed about all of these things in our last class. Then we also discussed about cloud computing. We discussed how to create a virtual machine, what is the virtualization technology. So some of the basic things we have covered in the last class. Today, we are going to start with some of the practicals, and we will see how can we build a CI/CD pipeline, and we are also going to learn about Docker. Okay, so that will be the agenda. And this is the current repository which I have created. I will again share this repository link to all of you if anyone has missed it. This is a repository where I'm going to upload all the code, all the files whichever I create in during the session. Everything will be uploaded in this particular repository, so you can get it from there and you can use it for your practice purpose. Okay. So in this repository, guys, there's a directory called as session screenshot. So whatever paint diagram I create during the session, you will be able to find out all those screenshots over here. So if you find them helpful, all these sessions screenshots are available in the repository under this session screenshot directory. Okay. Then if you see here, I have added one more document. This has screenshots. How can you launch a EC2 instance in AWS Cloud? So yesterday we have launched a EC2 instance. So this is a screenshot or the document which you can follow to launch a EC2 instance. Then here you will also find a README document. This README document has some content which we have discussed in our last class. I think guys, please don't draw anything in my screen. Or if we have anyone from the Geeks for Geeks, can you please tell me what is the exact setting to disable it from the participant? I think in the last class also we faced it a lot, right? So guys, please don't draw anything on my screen. Let me do the paint. Okay. So I will draw everything. You guys can just watch it. Please don't draw anything. It will disturb other people. Okay. So wait, I got some option. Wait. Let me check it. Do we have any settings? Mm, okay. So there is one more thing. Let me check some settings if we have over here. I'm not aware. So guys, I'm audible, I hope. Can anyone please confirm in the chat? I hope I'm audible to everyone, right? Okay. And one more thing, if you are not able to join this Zoom because I'm getting a lot of requests and I'm not able to admit all of them. So you can also watch it from the YouTube. Okay. So I will share you the link, exact YouTube link. Just give me a second. Okay. So this is the link. Okay, so anyone who is not able to join this particular class, you can watch it from the YouTube. And yes, you can revise it. Okay, I will revise you the concept which we have discussed in the last class. Okay. So guys, I think let's get started. I hope you guys will not draw anything on my screen. So in this README document, you will get a basic information. What is DevOps? How exactly we were working before DevOps? So what is the traditional approach we used to work? Okay. So in traditional approach, we had two kinds of team. One was our development team And then we have the operation team. Again, the responsibility of the development team is to understand the requirement from the business team and then write the code for it. Okay, so you will see here, if I again create the flow, so there will be a business team in your company. Okay, then there will be a market research team. Okay, so what this team will be doing, this team will keep on analyzing their customers. They will also analyze the market. Okay, how the taste of consumers is changing across the world, and they will also analyze their competitors. So this business team, market analysis team, their responsibility is to understand what is currently famous or what is currently getting popularity among their consumers. So they will keep on doing their research, and whenever they found something that okay, I saw that currently consumers are very much liking this kind of features in the application, so they will also try to bring same feature in their application as well. Okay, we took a couple of examples in our last class. One of the example was with TikTok. So TikTok was getting very much popular, okay, because they were offering one service where you can create short videos of 15 seconds. Okay, you can record those videos, you can share these videos in their TikTok platform, and everyone will be able to watch it, comment on it, and they can share with each other. Even they can take a reference of the audio which you have used, and they can also create a video. So a lot of features they were offering. Initially, your YouTube as well as your Instagram didn't have this feature. Okay, they were having a small feature where you can just upload a long running videos, and you can upload some post. That's kind of feature they have. But then they analyzed that okay, currently people are loving this particular feature, the short video platform kind of feature. Then both of these companies, whether it is YouTube or Instagram, they also came up with similar idea. YouTube came up with YouTube shorts, and then Instagram came up with Instagram reels, right? So what your company will do, company will keep on doing the analysis, and then they will keep on coming up with some idea. So here is the idea. Now this can be a idea for an existing company, this can be an idea for a startup as well. So if you are the owner of a startup, you will come up with the idea. Let's say you wanted to work in a field of diabetes, you wanted to cure diabetes, you came up with some new idea. That is the idea which you have built. Now, how you will take your idea to your consumer? So, how this idea will reach to your consumer? That is the main story. Okay. Currently, this idea is in your brain, in your mind, right? In your thinking. How this idea will reach to your end consumer, and consumer is the one, customer is the one who is going to pay you. Okay. So, this process from idea to take it to consumer comes under DevOps, you can say. Okay, that's what DevOps is going to help us. Okay, so DevOps is not a tool. Okay, it is not a program. It is just a set of practices which we should follow to take our idea to our consumer. Okay, and we should follow DevOps because of two reasons. The first reason will be it will give you the automation, and because it will give you the automation, it means your time to market will be very fast, very quick. Okay, because if you came up with some kind of idea, and then if your competitor came up with same idea and they have released their idea before you, then it's for no use, right? All people will start using your competitor's service, and then it will be a loss for you. It may be a loss for you. That's why all companies want that whatever new idea they are coming up with, that idea should reach to their consumer as soon as possible. They want their time to market to be very fast, and for that automation is going to help us. That's the first thing. Second thing is whatever idea they have, they are going to release it for their consumer. So they wanted to provide a good user experience. Means they want that they will have a good reliability. Reliability means consumer will rely on our services, and consumer will love to use our services. In that case, we want whatever services we are offering, it should be reliable. Means that service should not have any kind of bug, it should not have any kind of issues. Okay, it should not have any kind of downtime as well. Okay, so they want that whatever services we are releasing for our consumer, it should be in the best format. That's how the business will work, right? So how can we achieve it? Okay, so for achieving this, what we will be doing, we will follow a process. And these set of practices or process which we are going to follow comes under DevOps. That's what DevOps is all about. So all the companies, most of the companies which you see in today's market, they are going to use the same kind of flow to take their idea to their consumer. If they miss this particular flow, then it means they are going to make some mistake. So what are the flow we discussed? The flow is whenever idea will be, let's say, brainstorming. There will be a brainstorming which your business team, your CEOs, and everyone will be doing. Once the idea is ready, they will create one requirement document. In the requirement document, they will have the entire information, what exactly this idea is all about. Then this idea is going to be communicated to your development team. Development team is going to understand the requirement. As per the requirement, development team is going to decide the tech stack which they are going to use. They are going to use MERN, mean, some other tech stack. Okay, what kind of database they should use, what kind of programming language they should use, what kind of framework they should use. So everything development team will be responsible for. Okay, so as per the requirement, your programming language may change. As per the requirement, you may use some different kind of database. Okay, so your development team, as per your budget as well, they will decide what kind of tech stack they are going to use. Okay. Once they have the tech stack, means they have the relevant developers as well. These are the developers who are going to develop this particular feature. Now we have so many developers who are going to work on a single project, single use case, single requirement. So they want to have a centralized location where they can share the code with each other, where they can work in a collaborative environment. That is the place where we discussed about GitHub. So GitHub is the place. Okay, or you can say any centralized repository. GitHub is one of them, famous over here. They will keep on pushing their code, or you can say uploading their code over GitHub. And from GitHub, other people can pull the code. They can do some further changes in the code, and they will complete the development. Okay, so after some time, let's say they take few weeks and the development is completed. So now in GitHub, we have the latest code which is being developed by your developers. While your developers work for a particular use case, for a particular requirement, what they do, they develop it in their local laptop. They will test it in their local laptop, but there is no guarantee their code is good for the deployment or not. That's why here we are going to first test this code. Okay, we are going to perform some unit testing to make sure our code is properly being written, all the business logic, all the algorithm is properly working over here. So everything they are going to test. Who is going to test? We will test, right? So development team responsibility is mainly about understanding the requirement and writing the code. Okay, then we will have the operations team. Operations team responsibility will be to take this code and to make this code ready for the deployment in your servers so that it can be accessed by your consumer. So we will test it. Then we discuss about SonarQube, very powerful tool. Okay, that will help you to understand the quality of the code, whether the code has any security vulnerability, whether the code has any kind of bugs. SonarQube will be able to highlight these things for you. So SonarQube is going to read your code line by line, and then SonarQube will highlight you whether your code is written in a proper quality manner or not. If it is not, then your developer will have to update it. So I will give you a glimpse of SonarQube today in or today's class, how SonarQube will create a report, how SonarQube will tell you whether the quality of the code is good or not. We'll see it in today's class, right? Then we can perform some further kind of testing. We can check whether we are following all the standard, okay, programming standard or not. Guys, please don't draw anything in my screen. So we'll see, can we, are we following all the market standard for writing this particular code or not? Okay, let's say if we are following it, then only we will create our bundle, and then only we will deploy our code. Okay, deploy our code for our consumers to use. Okay, that is the flow which we are going to use over here. Okay, so do we have someone from the Geeks for Geeks over here in the chat? Okay, so where is that option to turn off the annotation? Ayush, if you can guide me. Like, let me check where is that. I see annotation button over here. Clear, save. Text. So anyone is aware where is that option and how can we? So I have deleted your drawings. That option I can see. Okay. Yeah. So Tommy, like GitHub provide you one repository. Okay. In GitHub, it also give you a way to create this kind of CI/CD pipeline. Similar thing GitLab also give you. So you can say they are providing you similar kind of services. Okay, whatever services they are offering, they will be different in the features which they are offering, different in the costing which they are offering, but almost same, you can say. Okay. So, okay, guys. So let's get ahead. I don't see that particular option right now. as such over here. Okay. So where is that option? I don't see that option to disable any innovation. Okay, guys, where is that option? I see a button for over here, but I don't have any option to disable it further. I can clear the diagrams which we are creating. Oh, guys, let me do one thing. Let's don't waste time over here. I will check it later. For now, let's focus on our agenda. If anyone will draw anything in my screen, I will remove you from. Okay, so in which corner? We have four corners over here, right? Okay, guys, let it be. Let's leave it for. Okay, I see here. Disable application from others. Okay, I have disabled it now. Let's see if it works. So once we bundle our application, what will be the next step? Now we wanted to deploy our application, but we will not deploy our application directly to our production system. So we'll take our application to dev environment. We'll take our application to QA environment. We'll take our application to staging environment. And then finally, we will deploy our application to production environment. And my user will be using my production environment over here. In dev environment, your developers will be doing one round of testing to make sure whatever features they have built locally, all these features are available in dev environment or not. All the features are working fine or not. But we don't know whether developers are have tested everything correctly or not. So what we will do one more thing over here. We will also test our changes in the QA environment, where we will ask a separate team for doing this kind of testing for us. There will be a QA team. QA team will be responsible for testing over here, right? Then we will deploy in staging environment. Usually in this staging environment, we can perform different kind of testing. We can perform regression testing, RT. Okay, we have a, like in your company, you will have a particular team, RT team, PT team. Okay, regression. Again, what is this? Spanning regression testing, and then the performance testing. Okay, so in short form, we call it as RTPT. Okay, for MES. Okay, so we are going to do regression and performance testing to make sure. Regression testing means whatever existing feature my platform had, my application had, is it affected by this new feature which my developer have created? Is it affecting or failing my any of the existing job? We have to check that. Then in the performance testing, we have to make sure whatever application we have created, is it giving us the response in the proper time? Do we have any kind of timeout over here? Do we have any kind of out of memory error over here? So we will check also the performance over here. Everything goes well, then we will deploy the production system and our consumers will be using. That is the bigger picture, I will say. Okay. Now, if you want to see how exactly it works, so what we discussed that if you wanted to deploy your application anywhere, the basic requirement is you should have an operating system. Once you have the operating system, in top of the operating system, you can deploy your application, whatever you have created. And for creating an operating system, you need a hardware. Okay, that is a basic requirement for us. How we will get the hardware? The one way could be we can go to the market. We have the money. We can buy all this hardware. We can buy a land. We can create our own data centers where we can put all these hardwares and then we can use it for our services. In that case, you have to pay a upfront cost, upfront money, and usually companies don't want to do it. And here, the entire headache for maintaining the entire data center will be in your head because you are the one who is the owner of that particular data center for that particular center you have created, hardwares you have created, you will have to maintain it as well. So if you don't want, then you can take this hardware on rent. In our case, we are using public cloud for that. Okay. And we have so many cloud providers. We are using one of them, that is AWS cloud. So we'll take these hardwares or resources from AWS cloud. We will take it on rent and we will only pay for the amount of usage we have done and for the duration of time we have used it. Only for that much we have to pay. So we'll take it on rent over here. Once we have this hardware, now we will need operating system. Now we have multiple choice of operating systems available. We have Windows, okay, from Microsoft. We have Mac from Apple, and then we have Linux as well. So in this case, we discussed in the last class, we are going to use Linux operating system. Why Linux operating system? Because Linux operating system is a lightweight operating system. It is very fast, very much stable. It is very much secure as well. And it is also open source. So it is also providing you a lot of customization. So you can customize this operating system as per your need. In case of Windows, I have a very limited access to customize it because I don't have the source code of Windows. Microsoft guys are the one who are managing it. So Windows or Mac is good for your day-to-day use cases, but for creating servers, Linux is the best choice. In Linux also, you can use the Linux open source kernel as well. Or what different companies have done, they took this Linux open source kernel. In top of this Linux open source kernel, they have added their own custom features, and then they call it as, or they start selling it as with their label. So it is like a labeling they are doing. They are just adding some more features and they are selling it with their name. And this is called as Linux distribution. So we have Linux distributions available, Ubuntu, Red Hat, Kali, and all are available. In this case, we are mainly focusing on Red Hat Linux. Okay. So Red Hat Linux we will be using. So all the commands, what we will see will be from Red Hat Linux. Once we have this operating system ready, we will deploy our application. Now we were facing one more issue over here. How will I get this operating system? Or let's say if I got this operating system, and let's say I have launched multiple operating system. Okay. So guys, I'm giving this revision to all of those students who were not there in the last class. Okay, just give me 5 more minutes and then we will start with today's agenda. So I have created 3 operating system. Each one of them have their own hardware attached because your operating system can be launched in a hardware, right? Hardware should be there. Okay. And hardware you can't directly share as well. So this hardware is dedicated only for my this operating system. Let's say I have 3 operating systems over here. It is called as bare metal. Okay. So your hardware is physically attached to your operating system and your operating system is using it. In this case, let's say in this operating system, I have deployed any kind of my application. And usually in case of servers or in companies, what you will see, you will be deploying multiple applications. So let's say here, I have application number 3, application number 2, application number 1. Multiple applications I have deployed. Let's say I'm Paytm. So I have a service for booking a movie tickets. I have a service for paying other people via their phone number. They can do UPI. I have a service for booking flight tickets as well. So I'm offering so many services. So I will be keeping them separate over here for security reasons. And let's say here I have deployed 3 applications. Now here we face an issue of underutilization of resources. So here my application 1 has very limited load right now. So it is only occupying 20% of my resources. Okay, means 20% of your RAM, CPU, time it is currently occupying. This application is currently in huge load. It is occupying almost 70% of your resources or almost 90% of your resources. Here, this application is, let's say, in less load, only 30% of resources being occupied. Same example you can take with Instagram as well. So Instagram offer you status service where you can, let's say, create your status, right? And people can view it. Then Instagram also offer you reel service where you can watch and scroll reels. Instagram also offer you post service where you can post your photos or videos. Instagram also offer you chatting service where you can chat with other people. Instagram also offer you a dashboard where if you wanted to publish any kind of advertisement, you can do that. So Instagram is one application, but they're offering so many services behind the scene. So let's say currently in Instagram, reel services is in huge demand, a lot of load is there. So what will happen? Now you are not able to utilize, okay, whatever resources which was left here, I'm not able to utilize. Although I have paid for these resources, but I'm not able to utilize. That is the underutilization problem. So we discussed this will be a very big problem for us for scaling our application. Scaling means if we have more load, I will have to launch more servers. Otherwise, my users will not be able to connect to my server and they will get a downtime. Okay, so I will have to launch more copy of my servers. And in this case, you will face underutilization problem. That's why we came up with a new technology. Okay, the technology which has changed everything and which gave the birth to cloud computing eventually, and that is virtualization technology. So with the help of virtualization technology, now you have to buy hardware only one time. You don't have to buy hardware for each of the operating systems separately. Buy hardware only one time, and then in top of this hardware, you can have your virtualization technology. Okay, virtualization technology enabled. Now, virtualization is a technology name, but the tool which will give you this service is called as hypervisor. Okay. Hypervisor, you can say. Then in top, with the help of hypervisor, you can now launch multiple operating systems. Okay. And each of these operating systems will be independent from each other. Each of these operating system will get their own set of resources. And in these operating system, if you go to this operating system will consider or will think that they have a physical hardware attached. But in reality, they don't have a physical hardware attached. Okay, there's a virtual version of the hardware created, which is assigned to them. Okay, so they are sharing the same hardware eventually behind the scene. And this concept gave the birth to cloud computing because now all those people who have the money, what they can do, they can buy this kind of hardware, bigger hardware in chunk. okay, not in chunk, I mean in a big amount of hardware they can buy, like AWS did. They open a data center in Mumbai, they buy this much huge amount of hardware. Now they are saying, come to me, make your request, I will give this hardware to you on rent. Because they are sharing this hardware, they are doing nothing, they are just sharing this hardware. So for the time being, when I will use this hardware, I will have to pay. As I will stop using this hardware, I will say, please remove my operating system. I don't want to use it anymore. My work is done. Then this hardware they will share with someone else. Now someone else will be able to use this hardware or this part of the hardware. Okay, that's why the cloud computing came up in the picture. So if you wanted to create your virtual machines, what I said, you can go back to your AWS cloud. In AWS cloud, we have a service called as EC2 service. We can go back here and we can launch a EC2 instance over here. So whenever you launch a EC2 instance, behind the scene, they use this virtualization technology, okay? And AWS is using a very powerful virtualization tool, okay? Behind the scene, they use Zen, okay? So it will launch this kind of operating system for you, and this operating system will be assigned to your account. So only you will be able to access this operating system. No one else will be able to access this operating system. So it is also a good way or secure way of accessing your system. Okay, but if you wanted to create this operating system or virtual machines, these are also called as virtual machines. Okay, virtual machines in short form, I can call it as VM. In case of AWS, we usually call them as instance. Okay, so if you want to create this kind of setup in your local laptop, then I have added one document in your repository. What you can do, go back to this document. Here you will see we have a PDF file attached. You can follow this PDF file. Okay, in this PDF file, what we did, we have just wait. Okay, in this PDF file, what we have done, we have over here, we have I have given you the steps like how can you install Red Hat Linux in your VirtualBox. VirtualBox is one of the tool which will work for you to create this virtualization setup. And now with that VirtualBox, right now, let's say I have a Windows as a base system, but in top of this Windows base system, I can install a Red Hat Linux, Ubuntu Linux, or one more Windows also I can install. So with the help of VirtualBox, so you guys can follow this if you want. Otherwise, in my training, I will be showing you this all the practicals from AWS cloud, because not everyone have this much of resources in their laptops, because this will require a good amount of RAM and CPU to work. Otherwise, your system will crash. So if anyone is interested, they can follow these steps. It is very straightforward, and your operating system or your virtual machines will be ready in your local laptop. Otherwise, if you don't have a good setup in your laptop, then you can use the cloud over here. Okay, in cloud also you can create a free account and you will have to pay only for the amount of usage you have done. Okay, that will be the agenda. So right now I will be using cloud. Everything I will be doing in the cloud. So anyone, okay, who want to do it, they can. Yes, Daniel, 8 GB should be enough. Okay, 8 GB would be a little slow, but it is enough. You can make it go. Okay, if you have 16 GB, that will always be recommended, but 8 GB is also. Okay. But if you create multiple virtual machines and you have just 8 GB of RAM, then that will cause some performance issues. Yes, OS the images will be needed to separately download. So if you wanted to create one more Windows operating system with the help of this virtual machine, so in that case, you will have to download the ISO file or the image file for Windows. Right now in this document, I am giving you the ISO file for Red Hat Linux. Okay, so from here you can download this ISO file. This file will be almost of 9 to 10 GB. Okay, this file I have uploaded it in my Google Drive. You can download from here and you can use it. Okay, so yes, it is Oracle VirtualBox. You can also use VMware if anyone is aware. So all these tools can. So guys, this is in your repository. So you can get it from the repository. I hope I have shared you the repository link a couple of times. Okay. Now guys, let's go ahead with today's practical. So I'm again going to create one virtual machine over here. I will click on launch instance the same way which I used in my last class. I'm going to launch a new virtual machine over here. You can see they are calling it as virtual machine. So I'm going to make a request to AWS that AWS, can you please create a virtual machine for me? Let's say GFG workshop virtual machine 1. Okay. Then they are saying which kind of operating system do you want to create? Red Hat, Windows, Ubuntu, Mac, what? So I will be using Amazon Linux over here. Again, Amazon Linux is one of the Linux distribution which is created by these Amazon people. Okay, but this Amazon Linux uses behind the scene Red Hat. So whatever command we can use in Red Hat, same command will be available over here as well. But Amazon Linux comes up with some more pre-setup. That's why I'm using it to make these practicals very straightforward and very simple for you. Otherwise, you can go with Red Hat Linux as well. Same commands will be available over there as well. Okay. Now, we can select this AMI. And guys, I would like to repeat, please don't try to do this practical along with me. Okay. Because right now, if you will try to do the practical along with me, it will look to you that I am very fast. Okay. Why? Because you are trying to do it as well as you are trying to understand it. And our human mind is not capable of learning or focusing on two things at a time. It's not possible. Even I can't do it. No one can do it. Okay. So we can focus only at one thing at a time. So please try to create your personal notes. Please listen me right now. After these 3 hours of workshop, you can try doing the all the practice. So don't do it along with me for now because these are very new concepts for you. So please don't do it. If anyone is already aware about virtual machines, anyone is already aware about Linux, some basic knowledge you have in Docker, then you can do it. That is fine. But if you are very new, then please don't do it. Otherwise, you will start missing the concepts. Okay, that is the uh, one of the suggestions from my end. Then once this virtual machine will be created, I am going to select a key pair over here. This key pair will help me to log into my virtual machine, to prove my identity and to authorize to this virtual machine so that I can get a terminal of it. So this virtual machine will be running right now in the Mumbai. So you can see we have selected the Mumbai as one of the reason. So in Mumbai it will be created, but I will be doing a remote login. So they are saying, do you have any key pair already created? I'm saying, yes. In the last class, I have created a key pair. That key pair name was GFG workshop. Same key I'm going to use here as well. This will work like a password for you. So it's not exactly the password. Password is not a good way of authentication. Keys are even much better than that. So here we are going to use these keys for authentication purpose. We'll do it in our next step. Okay. And then in the network settings, we can decide what kind of traffic I want to allow and everything. I'm going with all the by default options for now. And then because we are creating an operating system, whenever you want to create an operating system, you will also need a storage because you have to store all the operating system program files and other details. So here also they are going to configure 8 GB of SSD storage for me. Okay, that is enough for our practical. Otherwise, you can increase this value as well. So I'm going to launch my instance with this kind of settings. So your EC2 instance will be launched in a minute. And once it is launched, we will connect with this EC2 instance. So I will just click over here and then we can connect with this EC2 instance. Okay. So it will load in some time. So behind the scene from this bigger hardware which AWS have, now they have given a small amount of hardware to me as well. They have launched one operating system behind the scene, a virtual machine for me. And this virtual machine only has 1 GB of RAM and 1 core CPU. That is enough for our practicals. Okay. That is called as instance type. So we have selected the instance type as G2.micro, which comes under the free tier limit of AWS. Because you guys are new to AWS and you guys are not using it for enterprise purpose, you are using it for learning purpose. So AWS will automatically enable a 12-month free tier account for you. So most of the services will be free for you if you use them under the limit. Like in case of EC2 instance, if you launch this EC2 instance and if you run this EC2 instance for less than 720 hours in a month, then they will not charge you anything. If you go beyond that, they will start charging. And they are also saying if you will try to use more than 1 GB of RAM and 1 core CPU, I will charge you. But if you are using 1 GB RAM, 1 core CPU, I will not charge you because this is a very small resources. Okay. Now, if you want to connect with this EC2 instance, click on the connect button and then you can directly connect. So in the last class, we connected via SSH client. We open a command prompt in our system and we did it. But because we are using Amazon Linux, this Linux distribution is from Amazon people only. So they are also providing us a web UI to connect with it. So if you go to EC2 instance connect option and you just click on the connect button, okay, I'm already logged into my AWS account. So they haven't asked for any kind of password because I've already logged into my AWS account and they will open the entire terminal of my EC2 instance over here itself. Okay, that's what we are doing. Once you will log into your EC2 instance, okay, by default you are in a EC2 user. EC2 user will have a limited privileges. So what we will do, we will first switch to a user called as root. So now we have switched to root user. If you want to see what is your username, it is root. Same thing you have in Windows as well. So whenever you will like to log into your Windows operating system, they will always ask you, via which user do you want to log into the system, because different user will have different kind of privileges. So root is your admin who have all kind of privileges. That's why we are using root over here. Okay, but if you want, you can go ahead with EC2, or you can create a custom user as well. I can create a user for Sudhanshu as well. Again, that these jobs will come under Linux administration, and we will not go to that right. I can see a lot of you are asking about the recording. So recordings will be present, guys, in YouTube. You can watch it anytime. Okay, after this session, or even YouTube also, this session is currently live, so you can watch it from there. So don't worry about the recordings. Okay. So here, once I have logged in over here, okay, what else I can do? Okay. Now, if you wanted to create any kind of server, so you can create it. We are going to install one Apache server over here. Okay. So the name of the program over here is HTTPD in this case. So that's why we are going to install HTTPD over here. If you're using some different operating system, different, let's say, operating system, Ubuntu you are using, in that case, the program name will be different. Okay. So HTTPD is the program name for installing Apache web server over here. So what Apache will do, Apache web server will help you to create a web server where you can host your web pages, your static content. Okay. Everything can be hosted over here. So we wanted to start a server. That's why we are using Apache over here. You can use Nginx as well. If anyone is aware of Nginx, you can use Tomcat as well. So whatever you want, you can do it. You just have to remember, or you just have to search for the exact package name. So in my case, the package name is HTTPD, and Yum is your package manager who will help you to install your packages, to remove those packages, to update those packages. So if you want to do anything with the packages, Yum can do that for you. Okay, that's why we are using Yum over here. We are saying, Yum, can you please install this package for me? If you will say, Yum, can you please uninstall this package? So Yum will uninstall that package. If you will say, Yum, can you please also give me or update a particular package, then Yum update command you can use. So we have different commands available in Yum. If you want to know all the command, okay, so you can say Yum help. It will show you the help documentation for Yum command, and they will show you what all Yum can do for you. Okay, so Yum can give you the history. Yum can help you to install a package. Okay, Yum can reinstall a package, remove a package. So all these commands they have. If you wanted to know more about a particular command, then what you can do, you can also open a manual of this command. So manual will give you more information how a particular command works in Linux operating system. Okay, and in Linux operating system, we mainly work with CLI, command and interface, because we want to make it very lightweight. Okay, if you wanted to use GUI, like in Windows, I have a GUI enabled. That's why I can use my mouse and everything. So GUI makes your operating system very slow. Okay, because here in Linux operating system, we wanted to create a server. So we will disable GUI. If you want, we can enable GUI in Linux operating system as well, but mostly it will be disabled, and we will only use CLI. So everything you have to do it from the command. If you want to see what all option this command provide, because this command is created by someone else, you don't know. So you can just use manual, and you can say, can you please tell me, can you please tell me about Yum command? Okay, so if you use manual, MAN manual, and then you give the command name, they will give the information. What this command name is, what description about the command, what exactly it does, what value this particular program returns. Okay, so if it returns you 0, it means the command was successful. If it returns you 1, this command has some issues. Then if you scroll down, they will give you all the available commands in Yum. If you also scroll down, they might also show you some examples of some of the options. And if you scroll down, they might also show you who is the developer of this particular command. Okay. And if you find any kind of bug, any kind of issues in this command, how can you report it? Some email ID also they can give it to you. Okay. So this will give you the entire description, entire information about a particular command in Linux. So we have different commands available. Yum is one of them to install packages. Date is one of the command which can print date for you. ls is one of the command which can list down all the files which you have present over here. Touch is the command which can help you to create a particular file, empty file it will create. Now, how this touch command work, you don't know. Again, you can use manual or the touch command. Okay. Now they have opened the manual of the touch command. They will explain what exactly touch command does. Okay. And what are options we have in the touch command. Okay. So you can use all of them over here. Okay. Sarad, you were asking like how this AWS is solving that underutilization problem. So not just AWS, if you are using the virtualization technology, the problem is being solved because whatever, like in this particular case, some of the resources were underutilized, like over here in this particular example. Now, if your one of the operating system is not able to utilize some of your hardware, so in that case, that hardware can be shared with other people, other operating systems that you are running. So if I'm creating my own virtualization tool, let's say I'm using VirtualBox in my local system. In that case, I will have a capability. If one of my operating system is not able to utilize whatever amount of resources was given to it, then it can be shared with the other operating systems which are running over. Okay, that sharing nature, that sharing of the hardware is the base of your AWS cloud over here. That's what they are doing. They are sharing the hardware to you. Okay, and then now they're giving you an capability to select what is your requirement. So if you select for 1 GB and 1 core CPU, and now in this case, because you have already booked this much amount of hardware, so you will have to pay for it. Now you don't have any chance to share 0.5 GB to someone else, because now you're using someone else virtualization tool. You're using AWS virtualization tool over here. So if you have paid for 1 GB, you have to pay, you have to utilize. Let's say now you change your mind that you don't want to use 1 GB, then delete this instance. Ask AWS to give you one more instance with just 0.5 GB of RAM. They can do it for you. So you can change your instance type as your requirement changes or as you proceed ahead. Okay. So right now I have installed this Apache package, or let me install this Apache package. If you want to come out from this manual, just press Q over here. Q means quit. It will come out from here. Right now, if you want to install Apache package, I'll say yum install httpd and my package will be installed. Okay. In case of Windows, we just go to browser, we just download the exe file, and then we double click on the exe file, and then we install that package. In case of Linux, we will just give that package name, we will give the install command, and we'll install it for us. Once it is installed, now we have to run it, because currently this program is installed in your hard disk. But this program, if you wanna use it, you have to load it to your RAM, right? Like here, Spotify is installed in my system, but Spotify is not running right now. If I wanted to use Spotify, I will have to take my Spotify program to my RAM. I will click it and it will start. In case of Linux, you will use system ctl start httpd and your program will start. And now you can utilize it. You can go back to the IP address, especially the public IP address, and you can try hitting it over here and you will get your data. But right now, this data will not be visible to you, okay, or not available to you because of security groups or because of firewall. Okay, so there is some firewall rules set up by AWS guys behind the scene by default for you, and that particular firewall is not allowing you to hit or to come to this particular EC2 instance at port number 80, and that's why you got this. Okay, so here my EC2 instance is running in AWS infrastructure. So now the infrastructure which we are using is from AWS. This EC2 instance is running over here. If I want to use in this EC2 instance, I have started one server, that is your Apache server, Apache web server, and this server is running at port number 80. Okay, at a particular port number. You are somewhere outside, you are on the internet, you wanted to read or connect with this particular program. So by default, you will not be allowed, because we have a security group over here, firewall over here. So you have to go to the security group and you have to define that whenever I wanted to come to this EC2 instance, please allow me. And I will come via TCP protocol and over here HTTP. And I would like to come to this particular EC2 instance via port number 80. So can you please allow me? So you will have to go to your security group once again. Okay. So over here, I will go to my instance. I think my instance may be already open. I will click on the security icon over here. Then they will open the security groups. I will click on the security groups and I will be able to see what kind of traffic right now they are allowing. Inbound means who can come inside my EC2 instance. Outbound means where exactly my EC2 instance can go. So my EC2 instance can go anywhere in this world. So if there's a Google server running over here in the internet, somewhere Google is running. So from your EC2 instance, if you wanted to hit to your Google server, you can do it. So all the outbound traffic, all traffic which is going outside of your EC2 instance is currently being allowed. Only the inbound traffic is currently being blocked. Security group will allow anyone or anyone, if they are trying to go inside your EC2 instance, they will block them. But if anyone is going from the EC2 instance to the outside world, they will allow. That is the current rule. In the inbound rule, they are saying only for SSH traffic I will allow. This SSH is the one which is giving you a remote shell, remote terminal. via this SSH protocol, I am getting this kind of terminal where I am running my commands. Okay, this is because of SSH program. So right now SSH program is enabled. That's why I am able to utilize it, right? So I will change this and I will say, can you please add one more rule, and can you please allow HTTP traffic as well? Okay. And then I will say anyone in this world, this IP address denotes anyone in this world should be allowed. I will click on save rules and now I should be allowed. So you can see it's allowed. If you wanted to change the web page content, you can do it. I've shown you in my last class. If you don't put anything in the web page content, it will show you the by default page from Apache. And this message is safe. It works, means your server is running properly. Now, this program we are using, that is Apache. If you wanted to make any change in this program, so you can also update the configuration of your program. So if you want to see what exactly this program is doing right now, what kind of configuration, by default configuration we have for this program, in that case, we have a special file. Okay. So you can go to a special location. Okay. etc. So guys, etc is one of the directory in Windows, in Linux, where you will find out all your configuration file. So now I am going to update the configuration of my Apache server. So here I will go to etc httpd and conf httpd.conf. I think that is the location. Conf.d. Okay. Conf. Okay, let me just go till conf. Okay, I was using cd command, so it was not coming. Cd means I want to change my directory from one location to other location. Last time I was in my slash directory. Now I went to conf over. If you want to see what kind of files are present over here, just press ls. Ls will show you what are the files are present over here. And you will see we have one of the configuration file for Apache present over here, which we can use. Okay. And we can make any changes, configuration changes to our server. Okay. So if you want to make any changes, configuration changes to your server, you can open this file, and from this file, you can make your changes. Okay. So here, guys, if you wanted to make any changes to this particular file, this is again a file. In the last class, I was explaining you about cat command. And now if I use cat command, and if I just read this file is very big. You can see a lot of things is been printed over here. So anything updating in this file with the cat command is very, let's say, not possible, you can say. It's very hard. Okay. So in Windows, usually you have Notepad as your one of the editor, right? Where you can edit the things, you can do Control F, you can search for it. Similarly, in case of Linux, we usually use VI editor, especially in your Red Hat Linux. So here also we have editor VIM you can use, and then you can give your file name. My file name was httpd.conf. It will open this kind of interface in front of you. This is like your file editor. Here you can see your file. You can also update the content of the file. You can also search a particular keyword in this particular file. Everything what you see in Notepad is also available over here in your Linux operating system. Okay. So now in this case, I wanted to, let's say, first of all, check what is the by default configuration for my Apache program. So I will just do one thing. I will just go down. Okay. I will just go down. So here you can see right now they have mentioned that by default Apache server will be listening all the traffic at a port number 80. That is the by default configuration. That's why whenever I start my Apache program, it listen on port number 80. If you want to modify this, you can modify it as. If I scroll down, then you will see some more information about this particular program. Okay. I'm just going down, and you can see, if you remember in the last class, when we will have to put some of our web pages, we are putting that web pages in this location /var/www/html. In the last class, we did it. Why this location? Because that is a by default location where your Apache server will check for your web page or your content or your HTML CSS file. If you don't want to use this particular location, you can change this location as well. You can come here, you can update the file. Okay, that can also be done. Right now, I will just do one small thing. I will come back here and I will make a modification over here. So whenever you wanted to update anything in this VIM editor, okay, first of all, you have to enable the insert mode over here. Okay. Now, what is insert mode? Insert mode means I wanted to insert some data. Right now, I am just able to read it. I'm not able to modify anything. If you wanted to open insert mode, you will have to press a keyword, and the keyword would be I. As you will press I over here, it will automatically open this in the insert mode. Let me press I, and you can see in the bottom it is showing me insert over here. Means I can insert some data. I can remove some data, add some new data if I want. So let me remove this 80 and let me make it 82, for example. Now I want my Apache server to listen at port number 82. I have made some change. Once you made some change in Notepad, what you do Control S to save it. Here we don't have Control S to save it. We have a different combination to save it. Okay. Here, if you want to save your file after making any changes, you have to press your escape key plus you have to press W. W will save the file or save the changes which you have done in the file. Okay. So I will press escape key. Then you also have to press a column. Okay. So before W, you also have to press a column, this particular keyword. You can see I press escape key, then I press this particular keyword column, and then now I will press W, and then I will enter, my data will be saved. Once your data is saved, now you want to close this file in your notepad. What you do, you just click on the cancel button and just close, right? Here, if you want to close it, you have to again press escape key, you have to again press column, and now you have to press Q. Q means I want to quit this file. Okay, and that's it. Your changes have been saved and you have also closed this file. So whatever shortcuts or combinations I'm telling you over here, I will share a document as well for this, so don't worry. Okay, and you can see my file is now being modified. I have upgraded this file. So now my server should be running at port number 82. But if I refresh, you will see my server is still running at port number 80. Why? Because whenever you make any changes to your configuration, you should also restart your server to make it work, to apply your changes, to apply your configuration. Okay, whatever you did. So here, if you wanted to restart your server, you can say system ctl restart httpd and your server will be restarted. Okay. So you can see my server is restarted. It means now it will be listening on port number 82. So if you go back to your browser, if you don't give any port number, it is port number 80 by default because all the web servers works at port number 80. Now if I enter it once again, now you will see after it will load for some time and then it will fail because now my server is not running at port number 80. It is running at port number 82. So I will have to define my port will be 82 over here. But this will also not work. Why? Because in my security group, I have added one rule. Okay. The last time I said to my security group, only allow the HTTP traffic, and HTTP traffic usually comes at port number 80. So your security guard is going to check from, okay, on which port number do you want to connect? So last time I was connecting at port number 80, so they were allowing me. This time I'm trying to connect at port number 82, they will not allow me. So I will go back to edit inbound rule and I will add one more rule over here. I will say I have a custom TCP protocol, okay, which I want to use. TCP protocol is behind the scene used everywhere. Okay, then what is your port? You can see by default for HTTP, the port was 80. Here I will say my port is 82. And I want you to allow any traffic, okay, which is coming to my system at port number 22, sorry, port number 82, you should allow. And I will save this rule. And if I come back here and if I just refresh it, you can see now it is working in port number 82. So what I want to prove over here is that you can have a Linux operating system. You can create your web server. You can also update the configuration of your web server as per your requirement, as per the modification you want in your company. That is the basic thing with what we have done over here. Okay, this is about a web server. Okay, now I will show you how you can work with a Python application. Okay, how can we deploy or run a Python application over here? Right now, we have just created a very simple web server. Okay, where we are just seeing a very simple HTML file over here, script over here, nothing much. But now, if I wanted to run a Python application, so how will it be? How can we run a Python application or Python server over here? And once you have this knowledge, okay, you guys can also run any Java application over here, Spring Boot application, any other application also can be run. Okay, Node application if you have. Okay. Okay. So let's see if anyone have any queries still here, you can ask me because now we are going toward the flow of checking how a Python application can be deployed. And then now we'll see how a CI/CD pipeline also go. Okay. So guys, please don't share any kind of link in the chat. I see so many links are there. Okay. Okay, I can see. Ronak, you can rewatch the last session if you want. That is good, Suman, if you use Linux daily. So do you have any queries, Suman? Jenkins will come in a minute, Mohammed. Okay, so wait for some time. We will come to Jenkins. So Vishal, were you there in the last class? Because whatever I have done till now, if you will ask anyone, this is the same setup we have done in the last class. I've just give you a revision for 1 hour. You can imagine whatever I did till now. It same thing I've explained in my last class as well. Nothing new I did. Only few small things I did. Okay. So Sneha, I have already given a revision of 1 hour. Okay, we have to pick some other topics as well for today. So whatever I have explained till now, okay. So this was just a revision, right? Guys, you can again watch these videos from YouTube. Okay. I have already given you the link. This is the live link for today's class. But if you go back to Geeks for Geeks YouTube channel, you will be able to find out the recording from the last class. So you can do that. Now let's come back and let's see about Python application. So guys, what I did, I will go to my repository once again. And here I have created one repository for a Python application. So if you go to repository section, I will share you the link as well. This is a sample Flask application which we are going to use now. So let me copy the link and let me paste it over here. Okay, to every one of you. Sorry, let me paste it. Okay, so this is a link for a Flask application, a simple Python application I have created. Okay, and today we are going to see how do we deploy this kind of Python application. So if you see, we have a app.py file. This py file has the main logic of the application. So what we are doing, we are using one of the library, okay, over here, that is Flask. Flask is one of the framework in Python to create your web server. So if anyone is aware about Flask, Django, Fast, so many frameworks are available in Python. Flask is one of the older framework and one of the good framework you can say for creating your web application. So here in the requirement.txt file, we define all the dependencies, all the packages which is required for this Python application to work. Okay, in this case, I have, let's say, defined these many packages will be required for this particular Python application to work. Okay, Flask is one of them, PyTest is one of them, Flake8 and PyTest. Let's say I've given some of the list. These are your dependencies, okay, which will be required for this Python application to work. Then in the app.py file, we have the exact source code of this Python application. Currently, it is a single file, but in real world, you may have a bigger code base where you may have multiple files together. But this is a simple Flask application. Okay, I will give you a small glimpse of this code as well. So here we are creating one function in Python. We use def keyword to create a function. Okay, and here we are defining a route. Route means once this Flask server will be created, anyone who will come to the slash endpoint, okay, then they will be able to see this kind of response. This is a static response which we are sending over here. Then if anyone will come to this Flask application at an endpoint slash test, then they will be able to see this kind of response. Now here we are printing or we are directly returning a very simple static value, but here we may write a logic with multiple if else condition loops where you may be doing some calculation behind the scene, and then after it you will return a value. Okay, so tomorrow we are going to do an practical where we will be deploying a Netflix kind of application. So in that class, in tomorrow's class, I will show you how a real world application will look like. So there we will have some real world logic, we will have some loops, some conditions, everything will be there. Okay, so in that movie streaming application, a Netflix kind of application, it will be a full stack application. When you will connect to that full stack application, you will be able to watch movies, for example. So that practical will be for tomorrow, and that practical will have a good code base. Right now, for today's class, it's a very simple code base where we are returning a simple hello world kind of data. And then we are saying this particular server will be running at port number 80, and then anyone from anywhere in this world will be able to connect with this particular Flask. Okay, this is a Python code where I'm going to start or create a Flask server over here. Okay, now how can I execute it or run it? Okay, so currently this code is there in my GitHub repository. Okay, if I wanna use it or run it in my virtual machine in my server, what I can do, I can first of all download my code. So either you can convert this entire repository in a zip format, then you can upload that zip file to your virtual machine and then you can use it, or you can clone the entire repository. So I'm going to the code section and I'm going to copy this repository URL. I will copy it. I will go back to my virtual machine, and then in the virtual machine, I'm going to write one command. Let me clear my screen and let me go to my slash directory as well. I will clear my everything, and then I will say git can you please do one thing for me? Can you please clone this particular repository for me? This repository has my source code. I want the source code to be present over here as well. So I'm just cloning it. As you will try to clone, you will see Git is not installed in my virtual machine by default. So if you want to install it, you will have to again use yum command. As a yum, can you please install Git for me? So now you will see yum is going to install Git for me. I'll say, yes, please install it. And now Git will be installed in my system. Once Git is installed, so I'm going to download the code. Okay, so whatever process, guys, I was explaining you over the last class that we will be doing a testing of the code, quality of the code we'll check, standard process we are following or not we'll check. Everything we are going to do now. We are going to test each of these things one by one, and then we will deploy our code. Okay, so the first thing is we have to clone our repository. My Git is currently being installed. Now I can again run my Git clone command and I can clone this repository. And you can see this repository is currently being cloned, and I can see this repository is being cloned. If I do ls command, you will see here this a folder is created. If I switch to this directory, I can use cd command and I can give sample flask app. So what you will see, this particular, I'm currently inside this particular directory. And if I do ls command, now I can see the same file, app.py file, requirement.txt file, readme file, and all the files are present over here. If you want to open this file, app.py file, you can just use cat command and just you can use app.py. You can see the file is open. Okay. Now, if you want to run this server, for example, okay, although we should not run it, we should first test it as well. That's why you will see in the repository, we have a file with the name test underscore app.py file. In this file, we have defined our test cases. Okay, test cases are the ones, this is called a unit testing. This file will help us to test the functionality of our application, whether whatever logic I have done in the application is working correctly or not. Okay, so I'm just copying this once again and I'm going to paste it over here so I can explain you this file as well. Again, guys, this is not your responsibility. It's the developer's responsibility to create this kind of files, this kind of program. Okay, we are not in a programming class, but if you have a basic knowledge, that is always well and good. So in this test file, what I'm doing, I'm first installing one of the library PyTest, which will help you to create and execute these test cases. And how can you test whether this particular function is giving you the proper response or not? How can you test? So here you can see we have written a test code. We are going to hit to the slash endpoint. You can see we are using get method over here. We are going to hit to the slash endpoint, and we are going to use assert. Assert is like a if. It will check whether your LHS value is equivalent to your RHS value or not. If your LHS value left hand side is equivalent to your right hand side value, then it means the condition is successful. The test case is passed. So here in the left side, you can see what we are giving what is the status we have got, response status we have got while hitting this slash endpoint. And then we are checking whether it is equivalent to 200 or not. Because normally, whenever you make an API call and you get a response, if you get a 200 response, then it means the API call was successful. You have got the return successful, you have got the data successfully. Okay. So here we have added a condition that whenever I will hit to the slash endpoint, I will check whether my response code or my status code is 200 or not. If my status code is 200, okay, then it means, that my test cases are currently working fine. So guys, right now I'm explaining you the test cases, how the test cases are created, Python test cases. We are going to execute it as well. If you don't know how these test cases are created, that is fine. That's not your responsibility as a DevOps engineer, but I'm still giving you a background of it. So this is my Python code, where I have my business logic. Okay. Let's say here I have done my business logic. Now, before I deliver this code to my end consumer, I should test my code, whether my code is working fine or not, whether my code is giving me the proper data or not, proper response or not. I should test it, because if I don't test it, this code may have a bug, and this bug will reach to my consumer. So this is the first condition we have added. Then you can see here we have added one more condition, that is called expected text. Expected text means, because you are the one, okay, who has created this entire code, so you know that whenever this particular function will be executed, what exactly it should return, what is your expected value. So here we are saying my expected value is, let's say, hooray. Right now I'm just giving some keyword over here, just a string checking we are doing over here. But if your business logic involves a lot of mathematical calculations and formulas, then you may pass let's say you may call your function, you have an add function, as I was explaining you last time. It takes two parameters, and then it has some business logic. Right now the business logic is very simple, a plus b. Okay, so if you want to check whether this function is working properly or not, what you can do, you can call this function, add function, and you can give two values, 3 and 7 for example. And because you are giving the value and you know what this function should return, so you are aware my expected value should be 10. I should get 10 because 7 plus 3 is 10. Then you will check whether this value is present in the response which I got from my function as well. If I got 10 from my function as well, it means my function is written correctly. But let's say my developer have made some mistake and instead of plus, he have used minus. Okay, so from function, you will get something else. Okay, you will get -4. Now -4 is not equivalent to 10 because here we have a minus operator. So you will be able to identify that there is a bug. This is called as bug in the code. And then you can ask your developer to fix it. Okay, so here also we know the expected value is hooray. Then we are again adding one condition. We are checking whether in my response data, which I have got from my slash endpoint, whether that data has hooray keyword or not. You can see we are using in operator. You can use equal to operator. Equal to means left hand side should be equal to your right hand side, or you can use in operator. In means whether this particular keyword is present in the response or not. So you can see in my response also hooray is there. Here also I'm asking for hooray. So it means this particular condition will be successful. This test case will be successful. Similarly, we are doing it for the other test case as well, for the other function as well. So usually for all the functions which you are creating, for all the algorithms you are creating in your application, you should have an underlying test case as well, so that you can test the functionality of your application. Okay, that's what we are doing. Okay, so now I'm going to take the same example and then I'm going to see how exactly it will work for us. Okay, so here, let's say if I wanted to test this application, the first thing is I will have to install all the dependencies over here, Python dependencies. Guys, if you have worked with any programming language, they all will have their own dependencies. Python have their own dependencies. In this case, all the dependencies of Python are present in this requirement.txt file. In this txt file, I can see these are the dependencies for this particular Python application which needs to be installed. Because if you don't install, it will not work. Okay, it will give you the errors. So here, if you want to test whether everything is working fine or not, okay, so you can use PyTest over here. So they are saying PyTest is not present. Why? Because we haven't installed all the requirements yet. So you have to first install the requirement. So if you just follow the steps which I have done, the first step, guys, I am showing you everything manually right now, but once you know the manual approach, now we will see how this can be done with CI/CD as well. Okay, that will be automatically. The first thing what I did was I have downloaded the source code. That is the first step I did, right? Source code. The second step, what I'm going to do, I'm going to check whether I have the Python interpreter installed or not. Whether I have a Python installed or not. So by default in your Linux operating system, in most of the Linux operating system, you will see Python is pre-installed, so you don't have to worry. Otherwise, you can again use yum command and you can say, yum, can you please install Python for me in the system? And especially Python 3. Python 3 means Python 3 version. Okay, currently we have 3.13 version is running. And when I'm doing Python, yum is saying that you already have Python installed, nothing to do. It is already installed. So I don't have to install this interpreter. Python is already installed in my system. Then the second thing is you will have to install all these Python dependencies. And to install these dependencies, Python have their own package manager. Okay, in case of Python, the package manager is called as pip. So now the third step will be you have to also install pip. Pip is your Python package manager. Means pip is the one which will help you to install all the Python related libraries over here. Package manager. Okay. So now I have to install pip. So I'll say yum, can you please install pip for me? Okay. So I'm trying to install pip. So they have identified that, okay, are you ready? I'm saying yes, I'm ready. So they are now going to install pip for me. Pip is the Python package manager. Okay. So once we have the pip installed, okay, we can now try installing our Python dependencies. Okay, all the dependencies I have in my requirement.txt file, I can try installing them. Okay, so I say pip, especially pip 3, because usually in your Linux operating system you have Python version 2 also installed. So don't worry, you can just use pip 3 over here. That is a command. And you can say, I wanted to install all the dependencies defined in this particular file. And you can see as you do this, it will read your requirement.txt file. In my requirement.txt file, I have defined about the Flask package, PyTest package, Workzone package, Flake package, PyTest coverage package. All of them will be installed. And you can see a lot of sub dependencies of Python will also be installed over here. Why? Because Python package manager pip is very intelligent. Python package manager knows that if you want to install, let's say a particular package called as Flask. So Flask may require some sub packages to be installed. Okay, so all the package dependencies will be taken care by them itself. We don't have to worry. Okay, now you can see my package. All the requirements, everything is being installed. Now I can say PyTest. Can you do one thing for me? Can you please run the test cases? As I will do PyTest, they are going to start our test cases. They are saying test session start, and then we have defined two test cases. Okay, and they are saying both of the test cases are passed over here. Then they are saying both of the test cases are passed. So if you again check what are the steps we are doing, we have installed pip. After installing pip, we have installed all the Python dependencies. Okay, we have installed all the Python dependencies. After installing Python dependencies, the next step we are using PyTest command to test whether all the things are working fine or not, or we have some issue over here. So we will be able to test it with the help of PyTest. Okay. Now, once your PyTest has given you a green signal, means all of your test cases are installed, means are working fine. It means your logic is good. You don't have any issue in the logic. Okay. But if I do a modification in my file, okay, let's say I made some new modification in my file. If I go back to my repository, so I will go back to my repository. Let's say in my app.py file, I'm going to make a modification. I'm going to edit this file. And let's say instead of giving this content, okay, let's say I give some content 1, 2, 3, 4. So I'm changing my business logic right now. Okay, let's say I have changed my business logic. And then after modifying my business logic, I wanted to save my changes, which I have done. So here in GitHub, we have a commit option where we can commit our changes in the repository. And as I will do the commit means these changes will be stored in my GitHub repository. Okay. Now I wanted to check whether my test cases are still working or not, whether my test cases are still giving me a pass result or not. So what you guys think, will my test cases will give me the pass result this time or not? Last time they gave the pass, everything was good. But let's say my company gave me a new requirement. I was working on that new requirement. I have made some new modifications over here, and I have updated my data. So what do you think this time I will get pass or not? So I'm returning some other things. I have changed my business project. Last time the business project was something else. I have changed it. Let's try this, whether it works or not. So whatever new changes you have made, okay, currently these new changes are present in your GitHub repository only. Okay, if you wanted to check or if you wanted to pull these new changes into your server as well, because right now if I open my app.py file, let me again check app.py file, what you will see, I still have my older data over here. If you want to pull your newer data over here, you can use git pull command. As I will do git pull command, it is going to pull my latest changes. So they have identified that I have made some new changes in my app.py file, and you can see these new changes are currently being reflected over here. Pull means I want to pull some latest changes from my centralized repository, my GitHub repository. Okay. Now I will again try to run my test cases and will check whether my test cases are working fine or not. And now you can see my test cases have identified that I have a bug in my application. They are saying that I was expecting hooray in the response. That is the keyword I was expecting, but I have got something like 1, 2, 3, 4. And because left side value is not equal to right side value, so my test case is now highlighting that you have an issue and your test case is now failed. They are saying failed over here. If it is failed, it means I will not take this code to be deployed to the next step because this code has some kind of problem. So you will again ask your developers, the developers, can you please fix it? Again, guys, these steps we are doing it with manual approach right now. We are testing everything manually right now, but we will also see how it can be integrated with CI/CD pipeline in a minute. In some time, I will show you with CI/CD pipeline as well. And it will be very simple for you because once you know how to test these things manually, you will be able to do it via your pipelines as well. Okay, CI/CD pipelines. So once you get into this kind of issue, you will call your developer. Your developer is the one who will get to know. Okay, your developer will say, okay, let me update my test case as well. I have updated my logic. Okay, or let's say from the test case, he will identify it. Okay, I made a mistake while updating the logic. I made my basic logic is now changed. I wanted to add some data, but I forget. I have removed the data. I will again add this data. My data is again now added over here. I will again commit these changes. Okay, so now I have fixed my code. Okay, so once this is completed, once this is done, okay, we will go back here and then we'll again pull our latest changes from repository uh, to our server, and then we'll again run the PyTest. We'll again run our test cases, and now you can see my test cases are passed. Last time they were failed because I have written my logic and that logic was not matching as per my test cases. It means there was an issue with my logic. So I upgrade again my logic, and now it is working fine. So there are some kind of testing we are doing to make sure whatever application I'm going to release, that application is properly being tested and that application don't have as such any bug. Now you can also further integrate it with SonarQube and other kinds of static code and analysis tool as well. These tool will further check your repository, further check your code, and will identify if they find out any bug. So there could be some bug which you will not be able to identify while running your test cases, but SonarQube will be able to highlight it for you. Okay, so SonarQube integration, SonarQube we'll see in some time because that will involve its configuration. And configuring SonarQube will take almost 45 minutes, so we'll not go to that direction right now. Okay, so let's say we have performed all kind of testing over here. Okay, we have performed all kind of testing. Once you have performed the testing, now what else you want to do? Let's say after doing the testing, you wanted to deploy this application. Okay, so you can also check the lint over here. So a lot of testers are there for Python. Guys, I'm taking Python as a base because this is the easiest programming language I could have picked. Okay, so in Python, if you want to see whether your code which your developers have created, is it following all the community standard or not, whether this code is readable or not, whether this code has some kind of uh, misinformation or not. So everything your Flake will be able to give you. So again, this is not a library. They are saying please install this particular library, and then they are saying that please run your Flake test cases. So you can copy this command, go back, run it over here. Okay, and then they are saying nothing. Currently, they are saying everything is fine. Okay, so they are saying, let me just give my code name as well, or we can also define flakate if you wanted to select that different kind of code, okay, which you wanted in like for that particular errors or warnings. Okay, you want to check whether your code has that kind of error or warnings, you can test it. Okay, so I will use my flakate over here, okay, to test my Python application. So, so your PyTest will only run your unit test cases. Flake8 is going to further check the readability and the other ways how your code is created. These things will be checked by your Flake8 over here. So Flake8 will give you a basic information how your code is currently working over here. Okay. So you can again use Flake8 and you can see that right now I have some kind of file. Okay. And I think Python Flake8. Let me just check the exact command. Okay, Python 3. Okay. Okay. So, okay, now they are not doing this way. Now we just have to run our Flake test cases. Okay. So they are right now not doing anything. Let me just check Python Flake 8 test execute. Okay. Okay. So they are saying your path to the file. I'm doing the same thing. I'm just giving my file name, app.py. So they are not giving me any data as such right now. Okay, so I will consider everything is good. But let's say if you have any mistakes, okay, then Flake8 will able to highlight it for you. Flake8 will say, let's say in this particular code, you have given your name is not correct. Like whenever you create any of the function a name, you should use proper, let's say, naming convention. If you're not following this naming convention, again, that is a issue. That's the code which you are creating is not correct. That code has some bug. Okay, so as per your programming language, these commands will change. Okay, in Node.js, the command will be different. Java command will be different for running your test cases, for checking the quality of the code. This command will change as per your programming language. That is again the responsibility mainly of your developers to identify and to execute these test cases to make sure your application is written in the best quality. Okay, and once your application is now, let's say, created, you want to deploy this application. Okay, you want to run this application. Let's say I want to run this application in my dev environment right now. So if you want to run your application, you can just use Python 3 and then you can give your file name. My file name is app.py. As I will enter, you can see my Flask, okay, server is being started over here. And they are saying that we are listening to you. Okay, they are saying your Flask server is listening at this particular IP address. If you will connect this IP address and port number 80, you will be able to connect to it. Now, this is your private IP address, but if I copy my public IP address as well, and if I go back here, okay, and if I try to hit, you can see the data which I have defined in my slash endpoint. By default, if you don't give anything, it is a slash endpoint. It will give you the data. And if I hit to the slash test endpoint, sorry, slash test endpoint, okay, then it will give me the data that is highest on should test or whatever data I have defined in my code, same data will be visible over here. This is the same data which I have defined over here. You can see anyone who will hit to slash test, this data will be returned to them. Anyone hit to slash endpoint, this data will be returned to them. That is the exact logic we have written. Anyone of you also going to try, you can also try this. So let me share it with everyone. And let me run this. Okay. So if you go back to your EC2 instance, so you can imagine, I can see that how many requests I'm getting. A lot of 404 requests I'm getting. So, okay. So I can see a lot of people are trying to hit to this particular server, right? And here I have added some kind of print statement, let's say as well, inside home function or something. Okay, so you will see here I have printed one statement inside home function. So whenever you guys will do or execute my server, I will also be able to capture the logs, and these logs I can further utilize it for my testing purpose, for identifying any kind of bug I have. Okay, I will be able to use it. Okay, so what we are doing, we have started and we have created our very simple Flask server. Okay. And now let's consider one scenario. The scenario is I took one virtual machine. Okay. And guys, this is important. This is my virtual machine. In this virtual machine, I have launched my application. In this case, it is a Python application. Tomorrow, we will see a Node application as well. Okay. This Python application is running. Let's say right now, my application, I created some shopping kind of website. Okay. And this website got viral. Suddenly, I am getting more and more people who wanted to use my application. So initially, like right now, I have only 1 GB of RAM, okay, and I have only one core CPU. So I have limited resources, okay, attached to my virtual machine. If I get more and more load, my system may crash. Okay, although right now our application is nothing, it is just printing a static data, but it may be a application which will be doing a lot of processing behind the scene. So in that case, what will happen? Your application will crash. If you don't want your application to crash, then you'll have to scale your application. Scale your application. In that case, you will have to again create one new virtual machine. You have to ask AWS to create new virtual machine. Once this new virtual machine will be created, you have to again repeat these steps which I have done. Okay. So I have to again download my source code. I have to again install Python over here. I have to again install pip over here. Let's say testing I have already done in my initial steps. Testing I will not do again and again. Testing is already been done one time. Once your testing is done and you have released your software to your production system, now if you have more load, you will just scale it. Testing will not do every time. So these many steps: downloading the source code, installing the Python, okay, installing all the pip, installing pip dependencies. Then you may be doing some, let's say, configuration over here, custom configuration. So you have to again repeat these many steps. And right now I have a very simple program, but still you can imagine I have almost 6 to 7 steps. So if let's say my virtual machine is currently being occupied and they don't have much resources left, so I will have to launch one more virtual machine. And in that virtual machine, okay, I will have to redeploy my application. But the problem over here is that I can go back to AWS. AWS can give me the virtual machine. There's no problem. I can again launch one more instance. AWS will do it. But the only problem is I will have to repeat the steps which I have performed just now. And repeating this step will take time because I'm doing it manually. And because I'm doing it manually, so there's a chance also I might have missed some step. Let's say while doing the setup next time, I might have missed to install some of the Python dependencies. Then in that case, it will crash my application. And this is not one time. Let's say you got viral, you have to launch more virtual machines, more replica you have to launch, more servers you have to launch because you wanted to distribute your traffic. Because if all the traffic will go to your one server, then your server will crash. So you want to distribute traffic. You want some of the traffic should go over here. Some of the traffic should go over here. Some of the traffic should get distributed over here. Okay. So you want your traffic to be distributed to all your servers which are running behind the scene. In that case, all of your servers should be exact copy of each other, exact replica of each other. Replica copy of each other. I mean the same server which I have created in my this virtual machine, exact same server I have to create in my this virtual machine also. That's why when my consumer hit to this server, he will get the whatever experience he will get from here, same experience he will get from here as well. Okay. So if I go to any of the website in this world, let's say I go to again Amazon.com or any website you can take Amazon.com. So here right now I might have connected to virtual machine one of Amazon. If I refresh my page, I may connect to some other virtual machine, some other replica of Amazon server running behind the scene. Again, if I refresh, I may connect with someone else. But you can see every time I'm getting the same page, same response, same data. Okay, so for a user, he will get a very static, a very seamless experience. But behind the scene, the load will be distributed between these kind of virtual machines. And now here we have a problem. The problem is every time, okay, every time you will have to do the same setup again and again. And guys, right now I'm just doing a setup for a Python application, but when you will do a setup for other kind of application as well, these steps will be huge. Okay, and doing it manually is not possible. Okay, and launching these virtual machines or launching these setup, because if I have to do this setup manually, it will take some time. It will take 2 minutes, 3 minutes. But these days, the attention time of your consumer is very less. No one is going to wait for 3 minutes to make your server again up. If they hit to your server, they didn't got any response, they will switch to your competitor. They will never come back. Okay, so no one is going to wait for 3 minutes so that you can manually go and configure it. That's why we came up with a new and very great technology 10 years back. Okay, 10, 15 years back. Okay, and that is called as containerization technology. What is containerization technology did for you? They have made the entire setup very simple over here. They have said that if you wanted to deploy your application, I can do it in less than a second. Less than a second. Okay. So now we are going to learn about this containerization technology as well. Okay. So containerization is a technology name. Okay. The only requirement of this containerization technology is that you just give me your all the information about your server. So if you want to use this containerization technology, they have only one requirement. The requirement is you just have to give them your server's details. Let's say I will create one bundle over here. This is my bundle. I will call it as bundle. In this bundle, I will provide this technology. To this technology, I will provide all the details, all the steps which are required for deploying or for running my server. So in my case, let's say the first requirement is to install Python. Second requirement is to pull the code. Third requirement is to install pip package manager. Fourth requirement is to install Python dependencies. Okay. Then my fifth requirement is, let's say, to start my Python program. So let's say these many steps I have. So I can document all these steps and I can create one bundle, and then I can share this bundle and I can use this bundle to deploy my further application in less than a second. Okay. So containerization is a technology name. If you want to see more information about it, again, go back to the internet, just search about here container. Okay. Search here. So containerization with Docker involve packaging your application and their dependencies into a self-contained portable unit called as containers. So you can see they're calling you packaging your application. So here this bundle which I was creating is called as packaging your application. Packaging means in this package, I will put everything which is responsible for running my server, for running my Python application in this case. So everything, whatever is required, whatever configuration is required, interpreter is everything, I will bundle it in one package. And now this package we are going to use further to deploy our application. It's like a template you have created. So you can also call it as template in a simpler term. So if you wanted to do the same setup again and again, because you have to do the scaling, whenever you will have more load, you have to launch more replicas, more servers. Okay. So here, if you wanted to launch the same server multiple times, same application multiple times, so instead of doing it manual, please create one template. And then you can use that template to launch it multiple times. It will be very fast and there will be no chances of mistakes. Okay. That's why here also we are going to create this particular template. Okay. So if you go back here, okay, so you can see containerization with Docker involve packaging your application and their dependencies into a self-contained portable unit. This package can be shared anywhere, and this can be used to launch your application very frequently. They will be very fast. Okay, if you go to uh, Docker website, so guys, containerization is a technology name, and Docker is one of the tool name which uses this technology behind the scene. Okay, like virtualization was a technology name, and hypervisor is one of the tool which was using that particular technology, or who was working on that particular technology. Okay, so here, if you go to Docker, so Docker is one of the tool which will help you to create your containers, to containerize your application. Okay, so what is the definition? The definition is use containers to build, to share, and run your applications. Okay, to build and share and run your application, and you can run your application anywhere. Okay. And you can see they are saying packaging your software into a standard unit for development, or shipment and deployment. So this unit which I'm going to create, this bundle which I'm going to create, this will be a standard bundle. And now this bundle I can share or I can run in any of my environment. So as I discussed, we will have a dev environment. We will have a QA environment. Okay. We'll have a prod environment or staging environment. Multiple environments we will have. So I will create this bundle one time. Same bundle I can deploy in my dev environment to check everything is working fine or not. Same bundle I can deploy in my QA environment to check everything is working fine or not. If I get a green signal from both of them, then same bundle I can deploy in my production system as well. Whatever result you got from this particular case in dev environment, same response you will get in your production system as well, because you are using the same bundle behind the scene. Okay. So this bundle, this package, we can package our software an entire thing into one file, okay, one bundle, and this bundle can be used for running your applications very frequently. So you can see a containers is a standard unit of software that package up your code with all of its dependencies so that your application run quickly. Because we want our application to run quickly within a second, otherwise no one is going to wait for that much time. They will left my server. So here, because we want to run our application quickly, that's why we are creating one standard unit. We are creating a template over here where we are putting everything handy. And whenever I wanted to run my application, I will take this particular bundle as a base, and from this bundle, I will run my instance. In this case, it will be called as containers. I will run my containers. And these containers, your server will be running. Your application will be running, which your consumers can use it. Now you want to launch more copy of this server, you can do it in a second. In a second, you can launch more and more copy of this service because you had this image pre-created. Okay, this is also called as template. This is also called as bundle. This is also called as package, and this is also called as image in the technical term. We call it as image. So we can create this image, and now we can further use this image to create infinite number of containers. Okay, that's what will be our goal. Okay, so you can see Docker container image is a lightweight. It will be very lightweight. Okay, it will be an executable package. Means you will package your application in such a way that you just have to execute it. Rest of the things will be pre-installed, pre-present over there. And this package will have your code, your runtime, your tools, your libraries, configuration, everything will be present in this package. So nothing needs to be done manually every time. Okay, everything you will provide, and then via this particular image, we will be able to launch our servers very frequently, very quickly. Okay, and whatever images we will create, this will be standard. So everywhere, in all kind of environments, you can run them. If you run them in Windows, if you run them in Linux, same kind of features you are going to achieve, same response you are going to achieve. Okay, and Docker will provide you a good security as well. Okay, so that's how Docker is going to work. And one benefit of Docker is if you just scroll a little bit down, I will come to the architecture part over here. Okay, so here there is a comparison given between your Docker and virtual machine. I think, where is that comparison? Okay, I think they had a good screenshot. I think they might have removed it earlier they had, but let me show you the one comparison. Okay, over here. So what usually people start doing, they start comparing containerization technology with virtualization technology. But it is not like that. Both of the technologies are very important and both of them are used in the real world. Okay. So first, let me talk about virtualization technology. Okay, virtualization technology. In virtual technology, what happened? We have a hardware. Then on top of this hardware, we have this virtualization tool over here, hypervisor, for example. Okay. Then we can launch multiple virtual machine over here. These are called as your virtual machines. And then in top of these virtual machines, I can deploy my application. That is the final setup. I can run applications over here. And the best part of these virtual machines is all of them will be isolated. All of them will be independent from each other. So whatever I'm doing in this virtual machine, it will not interfere with the other virtual machine. They all are isolated with each other. They all are working on an independent environment. But if you take care of, or if you just discuss about the containerization technology, what happened in the containerization technology? You will again have a hardware. Obviously, hardware will be required if you wanted to run any kind of application. Then in top of hardware, let's say you will have an operating system as well pre-installed. And then in top of operating system, we are going to install Docker, your containerization tool, whatever tool you are using, you can install it. Okay, so we have Docker, we have Podman, we have Cryo, we have Rocket. So many tools are available. Docker is one of the pioneer in this field. Okay, once we have Docker installed, then what next? Now we can use this Docker over here to launch multiple containers. In each of these containers, we may be running a same program. They may be each a replica of each other, or they may be running a different program. So here my some web server may be running. Okay, here my some Nginx server will be may be running. Here my some Java server is running maybe. Here my some Python server is running maybe. So in the same operating system, we have launched now multiple containers, and each container is running a particular kind of program. Okay. So this one may be running also a Python program. Let's say Python program was in a huge load. So I have launched 3 copy of my Python program. 3 copy of the Python program is running over here. Okay. And the benefit of this containerization technology is each of these containers will be isolated from each other, will be independent from each other, independent from each other. So whatever I am doing in this container, it will not affect or interfere with the other containers. But eventually, all of these containers are using the same operating system behind this. Okay. In case of virtualization technology, what happened? Whenever you create a virtual machine, every time they create or initiate the entire operating system. And that's why creating a virtual machine takes time. They will take few minutes. Okay. If you have a very limited hardware, they may take 30 minutes to create a virtual machine. Okay. But so creating a virtual machine takes time. Why? Because they have to set up the entire operating system. And then in top of that operating system, you have to set up your application manually. But setting up the operating system involves huge amount of time. And operating system is always very bulky because operating system have their own kernel and that has its own packages, its own softwares. Okay, and that is very bulky. In case of containerization technology, they are not creating any operating system every time. Okay, they are just running your application directly. They are just running your application. And because they are not creating any kind of operating system over here, they are using a shared operating system. That's why they are also sometimes called as OS level virtualization. So whatever operating system I had, I have now divided this operating system to my multiple containers. And if you go to any of these containers, you will see that it will give you a feeling that you are in a very different environment. It will give you a feeling that you are in a separate server. But behind the scene, all of these containers are using the same operating system. Same operating system is used behind the scene by all of them. Okay. So now in top of one operating system, now we can divide one operating system into smaller containers. Okay. That's what will be our focus. So if you want to see how these containers work, so let me go back to my virtual machine one more time and let's see how these Docker containers will work. So let me stop my web server, which I was running, and let me install this package Docker. So I will say yum install Docker. Okay. So right now I am already in a virtual machine. I'm already in an operating system. Now in top of my operating system, I'm installing this program Docker. And once my Docker will be installed, I'm going to further use it to create my packages. Okay. I can see someone is spamming the chat. Guys, please don't send any promotional messages. Otherwise, I will remove you. Let me remove you, I think. I've seen multiple by you. So Okay. So now guys, what we are doing, we are installing Docker over here, right? Once Docker will be installed, what we will do, we will start our Docker engine. Okay. So I will say systemctl start Docker. Means I'm saying I have installed Docker. Now I'm starting my Docker engine. Okay, Docker server basically. You can just say your Docker engine, your Docker daemon, okay, is now started. Now this Docker will take care of everything for you. Okay, let's say I wanted to create one application, okay, and I want that application to be in an isolated environment, okay, and I want that application to be very launched very quickly as well. So first of all, what Docker will say that Sudhanshu, you will have to create one bundle. Okay, in that bundle, you will have to put all the requirement over here for running your application. Everything you have to put in this particular bundle. Once you do it, give me this bundle, and I will use this bundle, or you can say template, or you can say image. I will use this image, okay, to launch your containers, and it will be done within a second, less than a second. So now we have to first know or first understand how to create this kind of images. Okay. So if you want to create these kind of images, we can do it. I will show you how these images are created. But for now, let's use some of the images which is already been created by your community people. Okay. So what happened? Docker is very famous. This technology is very famous. Entire companies are using Docker right now. Okay. So there's a huge amount of community people, open source community. They have already created n number of images, n number of templates over the internet, and they have put all these images in a centralized location, and which is called as your image registry. Image registry. So registry means they have just decided one location where they have keep on putting all the images, okay, which they have created for different use cases. So every image is for a particular use case. And for Docker, we have the image registry that is called as Docker Hub. Okay. So now I'm going to pull some of the image from Docker Hub, and then I'm going to use it. Okay. So let me go back to my internet, and let me just hit to hub.docker.com. Okay. So, okay. So let me go to hub.docker.com. It should open. So guys, this is one of the image registry. You can find all kind of images over here. Okay. So that you can directly utilize them. For example, let's say you wanted to set up Apache server, HTTPD server. So you have seen just for setting up the Apache server, I did so many things. I first installed HTTPD software. Then I have started the HTTPD server. Then I have put some of my files as well over there. Then I have upgraded my Apache configuration file as well. So many things I did, right? So what some people have done, what community people have done, they have already created one image, one bundle for running the Apache server so that you don't have to do these many things from your end. You can just run it. Okay. So if you go back to your Docker Hub, you will see there will be images present for almost everything, for all the use cases. If you want to create a database, for example. So creating a database, if you would have ever configured a database, it involves so many things. Let's say if you want to configure a MySQL database. Okay. So configuring a MySQL database will take so many things. But now here, someone have already provided a MySQL image. I can directly download this image. This is an official image, more than 1 billion downloads they have. I can download this image and then I can directly use it. My entire MySQL server will be running. I don't have to do any configuration. I will just pull it and I will just use it. That's what I can do. Okay. For showing you some initial practicals, what I'm going to do, I'm going to select one of the image over here. That is, let's say Ubuntu. So Ubuntu is normally an operating system, right? And here I don't want to launch an operating system, but I want to get a feeling of Ubuntu operating system. So here the Ubuntu community people have created one Docker image that is name is Ubuntu, and this Docker image will behave like a Ubuntu operating system. So whatever you have normally in a Ubuntu operating system, everything, most of the things will be configured over here. Again, they have more than 1 billion downloads, and that is one of the official image. Okay. So now I'm going to use some of the images. Okay, and I will see how can I launch the containers. Once you know how to use these images, then we will also see how to create our custom images for our use case. Okay, that will be our next point. So I will go back here. Then if you see, once your Docker is started, you can see Docker PS command. Docker PS will give you all the containers name, okay, all the containers name which are currently in a running state. So right now you see they are seeing nothing over here. Means no containers are running. Okay. So if you wanted to create any container, we have a command over here, Docker run command. And before running this command, let me also show you Docker architecture. It's very simple architecture. Okay, very straightforward, very simple tool you can say Docker is. Okay, if you just get to know what exactly Docker does, it will be very easy for you. Let me just go to Docker architecture. Where is that website? Okay, this is our Docker architecture. Let me take a screenshot and let me give you a small view of this architecture as well. Okay, so let me paste it in a new place. Okay. Okay. So in this architecture, you can see what we will do. You will see, first of all, we have a Docker host. Docker host is the place like in my right now. What I did, I have a hardware. In top of hardware, I have installed one operating system. And in top of operating system, I have installed my Docker engine. That is the setup which I have done. So right now, this operating system on top of which I have installed Docker, this will be called as your Docker host. Docker host. Because this is the one who is hosting your Docker engine. Okay. In Docker, there will be a program called as Docker daemon, which is the main program. You will be communicating with Docker daemon, and Docker daemon will be the one who will create containers for you, who will take care of their isolation, who will take care of their security, who will take care of their resource allocation. Everything will be taken care by Docker itself. Okay. And we are the client of Docker. So we are DevOps engineers. We are the client of Docker. So we are going to run or give some or type some command. And via commands, we are going to interact with our Docker daemon, Docker engine, you can say. So you can see these are some of the common commands in Docker, Docker run, Docker build, and Docker pull. Similarly, we have hundreds of commands available. These are some of the common commands. So I will give this command or send this command to my Docker daemon. What Docker daemon will do, Docker daemon will ask me that where is your image? Where is your bundle file? Okay. So right now what Docker is saying that I have the location of this registry. Okay. hub.docker.com, the registry which we discussed. Okay. Docker is saying that I am aware about this particular registry. And here right now there are hundreds and thousands of images available. If you wanted to create any Nginx server, they have the image. PostgreSQL, they have the image. Prometheus, they have the image. So they have the images for all the different kind of servers and creation. So they are saying that if you wanted to use any of these images, what you will do, this is called a centralized registry. Centralized registry. Okay. Now this is my local registry. So right now in my Docker Hub, you will see we have hundreds and thousands of images present. If you go to explore section, you will be able to find all of them for all the use cases. Okay, there will be so many of them will be present over here. But what all images are present in my local system? So if you want to see that, we have a command Docker images command. This command will tell you that right now in my local system, I don't have any image installed. So in your local system, you will only install those images which is required for your use case. Okay. So in my case, I will go back to my document. Here was the document. I am first going to pull the image. Pull the image from my registry to my local registry. Once I have the image present in my local registry, then I can run a container from that registry. And this container is a running instance of your application. Here your application will be running. If you don't get this architecture, don't worry. Once I will show you a practical, it will be crystal clear. So I'm going back to my EC2 instance, my server. Right now, I don't have any image, but in my Docker Hub, let me open this in a new tab. So I will be able to switch very quickly. So in my Docker Hub, I have found out one image, let's say Ubuntu, which give me a feeling of a Ubuntu operating system, you can imagine. Okay. So I'm saying that this image is present in my Docker Hub, in my centralized registry. I don't have this image in my local system. So I will click on this copy command Docker pull Ubuntu. Okay. This is like a template which is present. I'm first going to download this template into my local system. Okay. Docker pull Ubuntu. And this is a one-time process. Once this image is being pulled into my local system, now from this image, I can launch hundreds and thousands of containers. So you will see if I do Docker images, okay, you will see one image is right now just now being pulled. And this image is very lightweight, 78 MB. That's it. And if you wanted to create a container from this particular image, then we have a command. That command is Docker run command. Okay, Docker run command. Docker run command means I have an image. This image I haven't created. This image is created by someone else. I'm using their image right now. And the image name is this one, Ubuntu. I will give the image name over here. And as you will do it, what happened? Your container will be created. But here they haven't given me any data, any error, any message. So whether this container was successful or not, how should I know? So I can again use Docker PS command. PS command will show me all the containers which are in running state. But I don't see any container running over here. It means my container may have failed. So if you want to see all the containers who are in running state as well as who are failed, you can use -a. A means all. And you can see I tried creating one container from this Ubuntu image, and this container is giving me a bin bash program. Okay. And this container got exited, means this container got closed. Why closed? Because you need to understand what kind of service your container is giving to you. So in this case, my container is giving me a bash program. What is this bash program? Right? This bash is the program which gives you this kind of terminal. Right now, I am able to have this kind of terminal where I can write the command, run the things. I can run my command, date command, ls command. I'm able to run this command because there's a bash program running over here, running in my system. Okay, so because this is working like a Ubuntu operating system, it's not an exact operating system, but it will behave like that. So it is also providing us a bash program. Okay, and if you wanted to connect with this container and do something, you should have an interactive terminal. This interactive terminal will help me connect with the terminal of this Ubuntu container, and so that I can communicate with my Ubuntu system over here. Okay, so whenever I use Docker run command, I have an option over here -I and T. I means interactive, T means terminal. I'm saying whenever you create this container for me, Ubuntu container, I'm just giving it one more time. Please give me or attach an interactive terminal for me. As I will do the enter, you can see in a second, less than a second, my container has launched and now I'm inside the container. Now I'm not in my base system. I'm inside this Ubuntu container. So you can imagine in my system, now this Ubuntu container is running somewhere. This was my base system, operating system. Here I have installed Docker, and now here Ubuntu container is running. And currently I am inside this Ubuntu container. So this container will give me exact feeling of a Ubuntu system. Okay. So like in Ubuntu system, you don't have as such any kind of like in Ubuntu system, you don't have yum, right? Yum is for Red Hat. Yum is your package manager. In Ubuntu, normally we have apt. As I will do apt, you can see apt is present. So it gives me a feeling like I'm in a different kind of server, but I'm still in my operating system. In my operating system, I have launched one container that is behaving like Ubuntu over here. Okay, I can see apt over here. If I do the ls command, then you can see this particular container will have their own file system. Means if I create some file over here, let's say I'm just creating some sample file a.txt, b.txt, some sample files I'm creating, and then if I do ls command, you can see two files are created. Now these files are created only for my this particular container. From my local system, from my base system, I will not be able to see these files which I have created over here. So whatever you are doing in this container, it is just available inside this container. So Docker is providing you isolation over here. And this isolation is very much important for your security, for your container security, for your application security. Okay. Because now if I will try to come out from this particular container, okay, if you want to come out from this container, if you do exit command means I wanted to exit from this container. But right now in this particular container, we have a bash program running. Bash is a shell which is running over here. Bash program is running. If you will exit anything, then your bash program will also be closed. So as I do this, what will happen? I will come back to my base system. Right now, I'm again back to my base system. And if I do ls command over here, you will see I am not able to find these files because these files were created only for my this particular container, Ubuntu container. From my base system, I will not be able to see it. And if I use Docker PS command, what you will see my container is again being stopped. Why it is being stopped? Because I press exit over here. Exit means exit the current program or current command which was running. Here a bash program was running. Whenever you click on exit, your bash program gets stopped. And because in this container bash program was running, as your bash program will stop, your container will also stop. So if you wanted to again start your container, you can use Docker start command. And you can give your container ID. Each container will have their unique ID. Okay. And then you can give your container name as well. So I will say container, Docker start, and then I will copy a name. This name is dynamically given by Docker behind the scene. Okay. I will copy this name and then I will start it. Okay, I'm just creating some dots right now. I will connect these dots in a minute. You will see. As I will do the start command, what you will see if I do Docker PS over here, my container is still in the running state. Okay, I have again started it. And right now in my base system, I was not able to see the file which my container have created. Okay, they have created some a.txt and b.txt file. I was not able to see it. Okay, but as I will go inside this container, I will again be able to see. Or even in my base system, it's like I get some file c.txt, 3.txt. These files I have created in my base system. But when I go inside my container, I will not be able to see these files. Okay, so let me use Docker command. And then if you wanted to go inside a running container, then we have a Docker attach command for that. And you can give your container ID or your container name. In my case, the name is Brave Buck, something like that. Let me just write it Brave. As I will do it, now you can see I'm inside that container, again the same container. As I will do ls command, okay, you can see my a.txt and b.txt file which I created is still available. Whatever I did in my local system is not available over here. So this container has its own file system. This container will also have its own IP address, you can imagine. We are in our own system, but this container will have its own IP address. If you want to check the IP address of this container, I will again go outside of it and I will show you how can you check the IP address of this container. Again, if I want to go inside of this container, if I use exit, then this container will be stopped. If you don't want to stop it, then we have a shortcut over here. We have a escape sequence over here so that you can come out from this container without stopping it. And that escape sequence for Windows is Control P plus Q. As I do Control, left control, okay, Control plus P plus Q, what will happen? Your container will still be running and you will go outside of your container. You will come outside of your container. So now you can see I'm again back to my base system. This is the IP address of my base system. And if I do Docker PS command, my container is still running. Okay. Now, what do you think if I create one more container from the same image, Ubuntu image? So will that container will be able to access the file which my this container have created? No, it will not be able to create. If I use Docker run command once again, okay, I can use Docker run command once again. I can again use, as I will do enter, you can see within a second, the new container will be created. So now I have two containers running in my operating system. Okay, and both of the containers are from the same image, Ubuntu. They are like a replica of each other. But this new container will have its own file system. If I do ls, you can see this container can't see the file which was created by my older container. So each container will be completely isolated from each other by default. Okay. Again, let me come out to this container. Now, if you do Docker PS command, what you will see, two containers are running right now. Okay. One of them was started just 30 seconds back. One of them is running from five minutes. If you want to see more information about this container, then we have a command Docker inspect command. And then you can give your name. Let's say my container name is a sweet cray, some random name they have given. As I will do this command, what you will see, this particular container have its own information. A lot of information is there, but right now I will focusing on IP address. So you can see this container have an IP address 172.17.0.3. So one of my container have an IP address. So each system, each container will have their own network as well. And via this IP address, you can connect with them. Now, these IP addresses are not coming from your real network card. There is some software defined network, SDN, Docker is using behind the scene, where they have created this kind of network card or networks for you. These are not real physical networks. Okay, these are virtual networks which have been created and we are using over here. So this is the IP address of my one of the container. If I go to my other container, last time I checked for sweet gray. This time I will check for this brave work, whatever. I'll just copy it. I'll use Docker inspect command. As I will do it, as I will again paste it, what you will see, this one have a different IP address, 172.17.0.2. Last one had 0.3, this one has 0.2. And guys, this is a one of the feature which we have discussed. The first feature is each one of them will be isolated. Second feature is they are so fast. Once I have the image, from that image, I can launch millions of containers within a second. They will not take much time. And now in this particular system, I can launch the containers with a different image as well. Let's say you want to launch a container which will behave similar to your Amazon Linux. So in that case, you can go back to your Docker Hub. And if you search here, Docker Hub, do you have any image for Amazon Linux? Okay. As you will enter, you can see one image is present from AWS guys. AWS have is official image from AWS guys. Okay. Where you can use this Amazon Linux. This will give you the same feature what Amazon Linux give you. Amazon Linux provides a stable, secure, high performance execution environment for application. More than 500 million downloads they have. So if you want to use this image, again pull it. Okay, you will pull it this image, and now you can use this image over here. Okay, and now this image will be working like a Amazon Linux system. Okay, I'm pulling it. Now if I do Docker images, you will see right now I have two images in my system. One is Amazon Linux and one is Ubuntu. And if you want to launch a container from Amazon Linux image, again you can do Docker run command. I can again use -it because it will also give me a terminal. And then I will say I want to use Amazon Linux. And while launching a container, if you wanted to give your own customized name, because if you don't give any name, Docker will give some name from their side. But if you want to assign some name from your end, you can use -name option. Let's say I want to give a name OS1. As I will enter, what you will see in a second, one more container has been created. Now I'm inside this container. And this container is different. This has been launched from a from an Amazon Linux image. So here in this container, it will have its own file system, its own IP address, its own packages, its own software, its own settings as well. So in these two containers, I was able to use APT because APT was a package manager for Ubuntu. But this container I have launched via Amazon Linux image. So here your yum will be again available. As I go back, as I do ls command, you can see I don't see the files which I have created in my other containers. But as I do yum, you can see yum is present over here because this is behaving like your Amazon Linux. Okay, because in the bundle, in the image of this particular container, it was defined that you should have yum installed. Okay, that's why we can directly use it over here. Now let me again come out from this container. I want to show you some more thing. Let's say you wanted to set up a web server. Let's say you want to launch a Nginx web server. Okay, so how can you do that? Again, you can go back. You don't have to install any Nginx software because if you want to do it by yourself, what you will do, you will follow the process. The process will be that you will first download your code. You will set up your Nginx server. You will start your Nginx server. A lot of things you have to do. But someone have already created this template, this bundle for us with all the pre-created settings, predefined settings or configurations. I can directly use it. So I can go back. I can just search, do you have any image for Nginx as well? Okay, so you will see we have an Nginx official build for Nginx is available. I'm going to use it. I'm going to pull it first. Let me pull this. Okay, and let me run it over here. So what you will see, your Nginx image will be pulled, and then I will be able to use my Nginx server over here. Pulling the image is a one-time process because you are downloading a template. Once you have a template downloaded, you can use Docker images. Now you will see we have one more image that is for Nginx. I can again use Docker run command, Docker run command, and then I can define my image name that is Nginx image. And now, as you will do it, let's say if you again do -it as such, not required, but if you do it, you can see now my Nginx server has been started. So whenever you create a container, within a second that container got created, and by default you get a terminal of that container or the output of that container. And you can see because I have created that container, now I can't do any other command. Okay, I'm stuck over here. Okay, that's why sometimes we also let me do Control C to exit it. Sometimes we also want to launch our container in detached mode, and for that we have a -d option. Means your container will be started in background and they will not eat up your entire terminal like this, the way they have eat up. They will run in background. As I will do this, enter this, what you will see, one container have been started. If I do use Docker ps command, you can see this container, Nginx container is right now running over here. And this container, because Nginx usually provide you a web server kind of service, so they are also giving you a port number. They are saying that this particular server is running at port number 80, right? So if you can find the IP address of this container, you can also connect to this web server. So without doing any configuration from my end, I use one of the image, I'm able to use it. Okay. So guys, for now, you can imagine Nginx is similar to your Apache HTTPD, but Nginx have some other options or some other customization also we can do, but we will not go in that direction in this particular training. Okay. But you can see it is also going to get a web server for you in a simpler term. Okay, you may install Apache server as well. You can again go back to Docker Hub. You can say Docker Hub, do you have something for Apache? So just search for the package HTTPD. You can see for HTTPD also we have one image available. Okay, and they have more than 1 billion downloads, and it's an official image. So I can pull this one and it will start my Apache server. So whatever I was doing earlier with a manual approach, same thing I can do it from this particular image. I can pull it and I can use it. Okay, I've already shown you for Apache. That's why this time I'm picking up Nginx. So if I find the IP address of my this Nginx container, I will be able to connect at port number 80 and I will be able to see my data. So let me copy this name of my Nginx container which has been assigned, and I will use a command docker inspect, and then I will give this particular name. And as I will enter, they will give me the IP address of this container. This container IP address is this one. So what I can do, I can use curl command and I can say I wanted to curl to 172.17.0.5. That is my container IP address. As I will enter, you can see I can get the data that is a by default data of your Nginx server. Means within a second, my Nginx server was running without doing any configuration because everything was present in my bundle file, in my image file, which I am using over here. Okay. And right now, this IP address, which I see, is a private IP address, which is accessible only from my local laptop, or you can say from a virtual machine. Because all these containers are running in virtual machines. Okay. Each of these containers are independent from each other. So I have launched one more container. Here, my Nginx is running. So I can connect with this container from my operating system because this is the base operating system where these containers are launched. So from this operating system, I can connect to these containers. I can go to their terminal. I can start them. I can check their output. I can ping them. Everything I can do it. You can ping also that IP address. Okay, so you have a connectivity from your Docker host. So the operating system where you install your Docker engine, it is called as Docker host. But if someone wanted to use this particular image from an outside world, then how can they do? How they can do it? Means this IP address, if I copy and if I put it in my browser, I will not be able to connect because this is a private IP address. Okay, only if you wanted to connect from internet, you will need a public IP address. Private IP address is only available in your local network, only available in my this particular operating system or virtual machine which is running over here. So if you wanted to connect to this container and you want to use this service from outside world, you can use. You will have to use public IP address, but you don't have the public IP address as well. Right now, we don't have a public IP address. So how can we connect to this container from the outside world? That is the question, right? Okay. To understand this, now I will have to explain you some very basic components of your Linux operating system. And guys, if you understand this component, then you will be able to understand how exactly your Docker works behind the scene. How Docker is giving you these kind of services. Okay. So let's go one step back and let's learn about some basic concepts of your Linux system. Once you know it, you will be able to see how can I connect to this content from outside world because we have to do a port forwarding. Okay. So, okay. So here, what I will do, the first thing is you may be aware that right now in this operating system, there are so many programs running, right? Similarly, in Windows also right now, there's so many programs running. Windows is my one operating system. Inside Windows, my File Explorer is running, my Chrome is running, my Zoom is also running, Paint is running, and my Notepad is also running. There's so many programs which is running in my Windows operating system. Okay. If you want to see these programs, you can use Task Manager. So Task Manager will tell you what all programs are currently running over here. Okay. Task Manager is saying that right now in your Windows system, you are running Paint, you're running Google Chrome, you're running a Zoom meeting. Okay. And then in the background, there are so many kernel or your operating system level programs are running, which you haven't started, but they are running behind the scene to make your system up. Okay. So you can see so many programs are running. Same thing if you want to visualize in a Linux operating system, we can do it from a command. They are also telling me overall 88% of your memory is being occupied. 21% of your CPU time is being occupied. 5% of disk is currently in use. Okay, they are giving me over here. Same thing from the Linux operating system. If you want to visualize how many programs are running, okay, we have multiple commands. One of the command is ps-aux command. This command will tell you all the processes running over here. So guys, this like in an operating system, these things are called as process. These are called as processes. You can see background processes. Here we have a command. We have multiple commands. Stop command, top command, multiple commands are there. ps-aux command is one of the command that will show you all the process which are running right now in your system. If you remember, I have started on Apache's software, right? HTTPD software. If you see system CTL status of my HTTPD software, which I have started in the beginning of today's session, you can see it is in running state. So if I want to see this information in my process, so you will somewhere my Apache HTTPD would have been mentioned somewhere because it's a long list. You can see here it has been mentioned that your Apache program is running, your HTTPD program is running over here. Okay, you can see HTTPD program is running. So whatever program you will start, it will be visible over here. Let me create a duplicate terminal so I will be able to better explain you. Okay. So I'm just getting a duplicate terminal over here. So just for the same operating system, there is two terminal. Okay. So let me just log in over here. And let me go to the directory which I have created today, sample flask. And let me also start my Python application, app.py. Let me use Python 3. As I will do this, and if I go back and if I check how many processes are running right now, okay, ps-aux command, they will also show me that there is a Python program running. You can see they are telling me there is a Python program is running over here. Python app.py command is running. And for each process, they give a unique ID that is called as process ID, PID. Okay. So the basic agenda which I want to explain you over here is that we have three things in our operating system, three main things you can say. One is your hard disk, where you store your persistent data. One is RAM, okay, and one is CPU. These are three main things you can imagine right now. So CPU, this is your RAM. So whenever you install a particular software, that software will get stored in your hard disk. Let's say I have installed Apache over here. I have installed a Python program over here. I have installed Spotify over here, Netflix over here. So all of these programs are present on my hard disk. Okay. But whenever you want to run a program, as you will double click on that program, you want to run it, that program will automatically load to your RAM. Why RAM? Because this program will have some kind of logic. And if you wanted to execute this program, you will need CPU information. CPU is your main brain who is going to execute all the program for you. And CPU can't read any data directly from your hard disk. CPU can read data from RAM only. That's why you will have to load your data first to your RAM. So whenever you start any program, that program will first load in your RAM. And whenever a program will load in your RAM, they will get a unique ID for tracking purpose. And this is called as process ID, PID in short form. So whenever you have a program installed in your hard disk, that is fine, it is there in the hard disk. As you will execute it, now that particular program will become a process. This is also called as process. Okay. So if you start multiple program, multiple process will be created in your RAM. Until the time your program is running, that process will be present in your RAM as well. These are process. Each process will have a unique ID called as PID for tracking purpose. And then this process will be further will get some time from CPU, and then whatever logic is there for this process will be executed by a CPU. CPU is the one who will execute everything for you. So RAM is going to store your data for a temporary basis. Okay. And then that particular data, whenever you run a program, it will become a process, and that is called as a process over here. So whenever you do task manager, they show you all the process. Okay. In case of Linux, you can also see their ID. So if I go back, so for Python program, you can see they are telling me that you have a unique ID over here. Okay. If you just go a little bit up, they will give you the exact column name as well. Okay. You can see PID. They're also telling me how much part of CPU and memory your process is using. Okay. So each one of them will have a unique process ID. In my case, my Python program has a process ID called as 34763. That is the process ID from Python program. And from this process ID, I can track everything for this particular program. This process ID is very important. Let's say this program is right now running. If you want to kill this program, stop this program. So what you can do, you can just take this process ID and you can kill it. We have a command over here, kill command. Kill. Okay, we can provide a mode over here. I will say 9. Please kill it over here. App.py. The process ID is 347463. 347 what was that? 463. Okay, and you can kill it. What happened? Python 37463. Okay, 37 37466. So what happened? You have killed the process. If you come back here, you can see your Python program has been killed. Why? Because every program, whenever you run it, it will become a process. It will be in RAM. If you want to do anything with that particular process, you can just track it via your process ID, PID. Now, if I again do ps-aux command to check how many processes are running, you will see Python program is not running right now because I have killed it. Okay, that process is being killed right now. Okay, so we can keep on running a process. We can kill it as well whenever it is required. So in a system, there could be multiple process running at a time. Okay. Now what I want, let's say this is my operating system. Okay. In this operating system, I'm running a particular process and I want anyone from the outside world who is outside of my operating system, I want that they can access my process. They can run this process. Because whenever you create a web server, what basically happen? You are running a process in your RAM and you are giving an opportunity to other people just to go to their browser and to access your application. Okay. So for that, what they are doing, they are from the outside world. They are trying to execute or they are trying to connect with one of your running process. By default, whatever process is running in your system, it is just for you. But whenever you create a server, that process can be used by someone else as well. Okay. So this is the final diagram I'm creating. So you can consider, I'm giving you a very good example to understand this entire flow. Let's say this is your apartment. Apartment is equivalent to your operating system. Okay. In operating system, we can have multiple process running at a time. Similarly, in apartment, we can have multiple flat at a time. Okay. So you can just consider this analogy to understand the entire flow, how we connect to a particular program running over here. Okay. So you can see apartment is equivalent to your operating system and flat is equivalent to your process over here. And let's say this is your HTTP process running. This is your Nginx process running. Here your Python process is running. Okay. If you want someone who is outside of your operating system, someone who is outside of your operating system, you want them to use your services, to use your Apache program, to use your Python program. So by default, they can't do it because it is part of your operating system. How someone else can do it? Okay, like here, I was running an Apache program. My Apache program was running behind the scene. Okay, and they have a unique process ID 27434. So if whenever you connect to my, if I just copy my IP address once again, whenever you connect to my Apache server, you hit to port number 82. What you do, you are connecting to my Apache server. How you are able to connect? I am not inside this virtual machine. I mean, I'm from the outside world. I'm doing it from browser. How I'm able to connect? Because I have enabled a port over here. Okay, so my exact process ID is 27434. That is my exact process ID. You can consider that this process ID is 27434. This process ID is for my Apache program. Okay, guys, this is a very long list and finding out a particular process ID is very hard every time. So what you guys can do, whenever you do ps-aux command, it gives you all the data. If you want to do a filter over here, okay, then we have an option. We can use pipe symbol and then we can use a keyword called as grep keyword. And then we can say, I wanted to filter only for those processes where we have a keyword called as HTTPD. Now they will show you a very limited data. And you can see for Apache, you have this process ID, 27432. This is your process ID. And the guys, the thing is, this process ID will keep on changing. So if you want any one of your user to use your program, they must be aware about your process ID. Otherwise, how will they connect? Because in this operating system, there is hundreds of program running. So whenever someone from the outside world wanted to connect to a particular program, they will have to tell, okay, I wanted to connect with Apache program. I don't want to connect with your Python program. I want to connect with your Apache program. I want to connect with your Nginx program, which is running in the system. So they will have to define that I wanted to connect to your operating system. And in operating system also, I don't want entire access of your operating system. I only wanted to connect to a particular program running in your operating system. How can they do it? So one of the way could be that they can remember this process ID. Okay, they can come to my operating system. Okay, operating system will have a unique IP address, that is your public IP address. Okay, so guys, let's say in my operating system right now multiple programs are running. Okay, so my IP address of operating system is what? This is my IP address. Okay. I am running. This is my IP address 3.10. This is my operating system IP address. Now, in this operating system, you wanted to connect with which program? Because there are multiple programs running. Let's say there's an Apache program running at port number 82, and then let's say there's a Python program also running. Okay. So it is saying someone else is using the port. Let me just go to my file once again. Okay. And let me just change the port number over here. Usually Flask works at port number 5000. Okay. 5000. Let me save this and let me again run this. Okay. So what I'm trying to explain, whenever someone is trying to hit to your application, you can imagine it a scenario. Let's say there is a guy who wanted to send a letter in your apartment. So what will happen? That guy will come to your apartment, and that guy is going to first meet to your security guard in your apartment. Then this guy will say that I have a letter which needs to be sent in this particular apartment. Then guard will ask, in this apartment, I have multiple flat. In which flat you want to send this letter? Okay. So my consumer or my this postman guy should know about the flat number. Same thing is happening in operating system also. I am running an operating system. My operating system have an IP address. This is my operating system IP address, this one. If I come to this operating system at port number 82, I will be able to see this kind of data. But if I come to same operating system at a port number 5000, I will be able to see some different kind of data. 5000 is not allowed right now. Let me allow it very quickly. This port number is not allowed from security group. So let me allow this. So you will be able to see how can we connect. Edit in bound rule. And let me allow one more rule over here, and the port will be 5000. I will say anyone in this world can connect. Okay. So now if you will try to connect once again, okay. So you are saying that I wanted to connect to this particular system. Okay, what? Okay. So I wanted to connect to this particular system. You are running a Python server over here. Okay. Something is wrong. I'm in the inbound role. I edit the inbound role. Okay. I have allowed everyone and my server is running at which port number? Sorry, I think I have started by mistake in port number 500. Sorry, guys. So let me just enable 500 only over here. Okay. Whatever, guys, I'm just giving a random number over here. That don't matter right now. You can give any number. Okay. So let me just change it. So you can see I'm able to connect. So I'm connected to the same operating system, that is the operating system IP address, because in this world, in this internet, there is hundreds and thousands and millions of operating system running. So if someone wanted to connect to your operating system, they will have to remember your public IP address. IP address will be unique, always unique. But whenever they hit to your operating system, okay, now they should know in this operating system to which flat they wanted to connect. In that case, this person should know your exact process ID. But the problem with the process ID is is dynamic. It will keep on changing. It will keep on changing. So right now, let's say for my Python server which I am running, if you guys just go back over here, if I again to ps-ops, and if I just filter for Python, you can see for my Python program, right now my process ID is 38026. If I give this IP, this port PID to my user, he will be able to connect. But the problem is, let's say if I stop my program and if I restart my program. So whenever you will restart your program, what will happen? Your process ID will change. It is dynamic. It got changed. Means process ID is dynamic. It will keep on changing. So there's no way left for us to give any kind of process ID to our consumer. Because as you will restart your program, your process ID will change. So every time you have to call your consumer, you have to tell your consumer, my process ID is changed. Now you have to come to that address. It's not possible. That's why what we do a mapping over here. We do a mapping between your process ID and a port number. That's why port number comes in the picture. Port number is a static number, okay, which we can give to our consumer so that our consumer can come to our operating system and can connect to us. So port number, let's say here I have defined port number 500. So behind the scene, what happened? My user will come to my operating system and will say, operating system, I want to connect to your one of the service, one of the process who is running in port number 500. Now, behind the scene, what an operating system will do, operating system have a table. If you do that table, we have command net stat hyphen tnlp. If you run this command, it have a table. It is saying anyone who will come to port number 500 in my system, they will be mapped to a process ID whose ID is 38156. You can see your port number is mapped with a process ID behind the scene. And you can say 38156. This will be automatically taken care by your operating system. So now I don't have to give this kind of process ID, which is keep on going to be changed. I will not give it to my consumer. I will give a static number to my consumer so that my consumer will always remember it. In this case, let's say I have given a number as 500. So whenever my consumer will come to my operating system IP address, and whenever they will say that I wanted to connect to your system at port number 500, then this request will be received by your operating system, and operating system will automatically find out that this particular port number is currently mapped with this process ID 38156, and they will automatically let you to connect with this particular program. That's a thing which is happening behind the scene. It means anyone from the outside world, they wanted to connect to any of your program over here, any of your program over here in your operating system. Okay, you will have to expose that program. Okay, so right now I'm saying my Python program is right now running. Other than Python program in my system, okay, in my system, there are so many other programs also running. But because other programs are not mapped with a port number, so my outside world person will never be able to connect to my other programs which are running. Some bash program is running, some other kind of program is running. They will be able to connect to only to either my Apache program, because here a port mapping is done, or to my Python program, because here also port mapping is done. So your postman is always going to your apartment security card. Security card is nothing, your firewall in this case. And then it will tell that I wanted to come to your apartment, means your operating system. Then security guard is going to check his rule book, okay, inbound rule. And then in the inbound rule, if it is allowed, then only your security guard will let you or let this customer come inside your process and will let your consumer to connect with your process. And then your consumer will be able to connect with this process. So it is something like your port number is something like your flat number, you can imagine. So in an apartment, every process, okay, will have a unique process ID. But if you want these flat to be accessed by some outside world people as well, so you will have to give them a unique number. Let's say here I have given a number 500. To him, I have given a number 80. And obviously, this number should be unique. You can't give same number to two flats. It's not possible. Otherwise, if anyone would try to come to your apartment, they will get confused to which flat I have to give that later. If two flats have the same number, that's why two system can never have, or two process can never be mapped with the same port number. Always a unique port number. Let's say you want this process also to be accessible from the outside world, you can run it in port number 82. And you don't want these to be addressed. These are very internal programs. You don't want anyone can connect to them. Then you don't expose them. Don't attach them with any port number. No one will be able to connect to it. Okay, that's how it works. So we have to define exact port numbers over here. Same thing we have to do it for Docker containers as well. So whenever you launch a Docker container, behind the scene, what Docker is doing, Docker is creating one process for you. So right now there is three processes running over here. One is for my first container, second process is for my second container, and third process is for my third container. Okay, so Docker is doing nothing. Docker is just creating a process for you. Okay, it is something like you are downloading a exe file, a bundle file. As you click it, a process will be started. Same thing Docker is doing. That's why you will see, if I go back to my system, in my system right now, I don't have any Nginx package. I don't have any Nginx package. But because I have created one container where my Nginx server is running, so if you check your process ps-aux command, and if you just grep for Nginx, you will see one Nginx program is running. How is it possible? Because Docker behind the scene do nothing. They just create a process for you. And this process will also have a unique ID, process ID. So if you want that anyone from the outside world will be able to connect with my process, so in that case, you will have to map it with a port number. Until you will map it with a port number, you will not be able to access it. Okay. So now I want that this Nginx server can be used by someone else. Okay. So in that case, I will have to map my Docker container with a port number. And this concept is called as port mapping. Very important concept. So whenever I am going to now launch my container. Okay, I will define as a Docker. I wanted to launch a container for Nginx image. Okay, and I will run it in detached mode, let's say. Okay, then here we have an option -p where we can define a port mapping over here. And right now, each of the container which are currently running, okay, these containers are just getting a process, but this container have a private IP address. No one can directly connect. So here a port mapping will be done. Okay, port mapping in such a scenario, I will say anyone who will come to my system at port number 81, let's say, then they will be mapped with port number 80 running inside my container. And this is a very important line, guys. What this line means? This line means, first of all, my container is running in a private environment. So it is not accessible from the outside world. If you want it to be accessible from the outside world, so we are defining a port over here, that is port number 81. So we are creating a port, we are matching or we are mapping our program, Nginx program, which we are creating with a port number. We are saying anyone who will come to my apartment, my operating system at port number 81, then they will be mapped with my container, which is running in my RAM right now. They will be mapped with my container. And inside my container, there is a web server running, and web server typically runs at port number 80. So we are saying anyone who will come to my operating system at port number 81, they will be mapped to port number 80 running in my container. That is your web server. This is the port mapping. This was a simple concept. I could have given you this command directly, but I took some time to explain you the entire story behind the scene. Okay, but you can just run it. Docker will do everything for you. Now, what Docker will do? Docker will create or listen or will start listening on one more port number, that is port number 81. So if you do net stat -t nlp, so what you will see, Docker is saying anyone who will come to port number 81 of my base system, they will be mapped with a process which is running at this particular ID, process ID. And this is what is this? This is a Docker proxy. So this is your basically whenever you start a container is doing nothing, it's just starting a process for you. Okay, and this is your process ID 38736. If you just do ps-aux, and if you just do grep nginx, so what you will see for nginx, there will be a process ID 38736 which will be present. Okay, what this process will do for you, this process this is a proxy name. Basically this proxy name will take you behind the scene to your container. Okay, right now you will see two nginx program running. Why two nginx program? Because two containers are running with the nginx system. Okay, this is a proxy which will take the request from your base system and then it will proxy it to your container. So now, right now, my container is running in a private environment, but I will be able to access that container from the outside world via this port mapping. So I will copy my IP address and I will connect at port number 81 because that's what the port mapping we have done. Let me go back to my security group. Let me allow one more rule over here for 81. Otherwise, my security guard will block it. 81. I will say anyone in this world, save rules. I will go back to my IP address at port number 81. And what you will see, my Nginx server is accessible. So this Nginx server is not running directly on my base system. This Nginx server is running on my container, but I'm able to use it from the outside world. So it is an example of containerized application which we have created. So we have containerized one of our application and now we are directly able to connect to it. So guys, is it clear what we are doing? Okay, so what about others? Is it clear? See, guys, we have very limited time. Okay, 3 hours we have to cover so many things. So I will be picking up only those important things which are required for this workshop. Although DevOps is a very vast technology. If you have any specific question, you can always ask. Sir, you are saying that in your local host without Docker, I was able to run. Yes, you can run your program at different port number. There's no problem. Without Docker, also you can do. Now, why are we using Docker? If we can run our program at different port number, you can run your Spring Boot application. You have multiple applications. You can run them in different port. Docker is special because of a reason. Why? Because now you can imagine if you just go back to the architecture of Docker, which we are using, what we are saying, we have one operating system. Now, in top of this operating system, now we are launching multiple applications. We are running multiple applications. Let's imagine you are not using Docker technology. Okay, so you have one operating system. In one operating system, you are running Netflix as well. You're running some Spotify, some Apache server, some Spring Boot application, some Nginx, so many things you are running. But you have only one operating system, and this operating system has a limited resources. So now, how will you distribute the resources between your programs which are running over here? By default, your operating system will give equal priority to all of your services which are running. Okay, but let's say here for your Apache server, you have more priority. You want to give more priority, more resources to your Apache server. So how can you do it? So here you will have to go to your kernel and you have to ask kernel. Right now you have 80%, let's say 8 GB of RAM. My Netflix application is not that much important for me, so I wanted to add a limit over here. Because if you don't add a limit, and if you're running some kind of application, and that application may have a memory leakage or may have some problem, and it may happen that this application started occupying 99% of your RAM. And because your secondary application started occupying 99% of your RAM, so your main application will now be start getting crashed. So in one operating system, we are running so many applications. Okay, it may happen that suddenly one application started occupying most part of your resources. So it will start impacting your other programs. So in this case, in your Linux kernel or in your Windows also, you can add a threshold. You can add a limit. And this is called C groups. So we can add a limit that this particular program will never be able to use more than 10% of my resources, because this program is not very much important. For this program, I will add a limit that this program will not be able to use more than 5% of my resources. This program is important for me. Here I am running my Apache server. So I will say this program is important. I will allow this program to use up to 90% of my resources at a time. By default, your operating system will distribute your CPU time equally between your programs. But because this program is very important for you, so you can say CPU, you have to give almost 80% of your time for this particular program. Whatever will be left, you can give it to other programs. Means you can do a prioritization over here. If a particular program in your operating system is very important for you, you can set a priority. And these things can be done in an operating system, but for that, you should have a very good knowledge of kernel. In kernel, we can create C group rules. Usually, I talk about it in our Linux administration class. You can create some C group rules, limitation, and you can limit a particular program. Your program will never be able to go more, or will never be able to use more than that resources. But what Docker is doing, Docker is making these things very easy for you. So in Docker, if you are creating a container, so you can specify the priority of that container. You can specify how much maximum amount of resources this container will be able to use at a point of time. Let's say I'm going to launch a container Docker run, and let's say I will be using again the DIT Amazon Linux image. And let's say this container is not that much important for me. So here I have a tag hyphen memory. And then I can say this will be able to use maximum 30 MB of RAM. That's it. So I'm adding a limit over here to this container. And this container will not be able to use more than 30 MB of RAM at any cost. So with the help of Docker, you can also add a limitation. You are getting a proper isolation. You are able to launch your container very fast. And then you can also limit them as well. If you're not using Docker, you're directly doing it in your base system, then these kind of limitations, security, right now, all these containers are secure from each other. Okay, they are independent from each other. We can create a setup in such a way that even if this container got hacked by someone, they will not be able to hack my other containers because they all will be isolated from each other. Doing these things directly in a Linux kernel is very hard. Okay, but Docker is making all these things very easy for you. Okay, that's why we are using Docker. Now you will see this content. I have set a memory of 30 MB. So if I use a Docker stat command, let me just do the PS first, and just let me do Docker stats, and my container name is beautiful book. Let me just copy this. Okay. So you can see here right now my container is using only 1 MB, but you can see there's a limit of 30 MB. So my container will never be able to use more than 30 MB. So while launching my container, I can add some limitation as well as per my requirement. Because I have a single operating system. In that operating system, I'm doing so many things. I have to distribute my resources. So with the help of Docker, you can do it very in an intelligent manner. That is also one of the reasons why I are using. One more reason why Docker is so fast, because we are creating this kind of image beforehand, right? So whatever image I have created, okay. So this image we have to create first. Once you have the image, now from this image you can create your container. This image I also call sometime like as a recipe. This recipe or this image you can create one time, and from this recipe or image you can use it multiple times. You can use this recipe or you can launch container from this recipe multiple times. So guys, let me give you one more example and then I will switch to Jenkins. Okay. So guys, today's class will be extended by 10-15 minutes. Okay, because we have to cover this topic anyway. So anyway, this is getting recorded, so you can anytime watch it. But I will extend this class for a few more minutes. I hope it is fine for all of you because we all are here for learning. So if I'm giving you something extra, I hope that should be fine, right? We'll extend this class for a few more minutes, okay, for today at least. So one more analogy I wanted to give you why Docker is so fast, why Docker is able to launch containers so fast for us. Okay, so guys, let's take an example, very powerful example. Let's take an example that you went to a restaurant. Okay, in this restaurant you went and then you now ordered, let's say some food item. Let's say anything. Let's say you ordered some like paneer, for example. So you went to a restaurant, you ordered a food over there. So what is the usual process in a restaurant? They will take your order, that order will go to their kitchen. In the kitchen, they will have their chef. What this chef will do, this chef will start cooking this particular food item from the beginning. They will take the paneer pieces. So they will have the entire recipe for creating a kadhai paneer, for example. What will be the recipe? The recipe will be that first they must have a, let's say, paneer. Then I don't know how to make it, but let's say paneer. Then they will have some gravy as well. Then they will have some other, let's say, masala and all they have to add. So many things they have to do one by one, and then only their outcome will be ready. This is their outcome which they want. Okay. So to give you this outcome, they have to follow a process. They have to follow a recipe. Then only they can give you a good taste, a good item, food item. But the only problem is whenever you will went to this restaurant, whenever you will order a particular food item, creating this recipe or creating this food item will take some time. It may took, let's say, 30 minutes to cook this food. And after 30 minutes, they are serving this food to you. You will be happy. This is a fresh food. But the problem is it took some time. It took 30 minutes. And nowadays, no one wanted to wait for that much time. So nowadays, what companies are doing? Companies are using the same concept which we are using in the software world. Okay. Now, okay. Now, what companies are doing? So let's say I wanted to create one application. Creating an application involves so many steps. What is the first step? The would be I have to first install my Python interpreter. Interpreter. Then after installing my Python interpreter, I will have to download my code. So creating or deploying an application is nothing. It's just like a recipe you are building. This was a recipe for a food item. This is a recipe for your application. After that, you will take your code. Then what next? You will install your pip3, that is your Python package dependencies. Then what next? You will install all your Python dependencies. Okay. So you can see for running the application also, it is not a single task. You have to do so many things step by step, okay, one by one, and then your application will be ready. After installing your Python dependencies, you might be doing some configuration as well. And then finally, you will run a command. The command will be Python app.py, and that's it, your server will start. So you can see starting a Python application, running a Python application involves so many steps. The same things are applicable for running any kind of application as well. Okay. Now let's say if you come back to the older example where I was creating a virtual machine manually, and whenever I had to scale my virtual machine, means I have to scale my server. What I was doing, I was manually creating a new virtual machine, then I was manually doing the same setup again and again. And doing this setup again and again is a time taking scenario, and that's why doing scaling was very hard over here. So to solve this, what we did, we created one bundle. We created one recipe over here. What we did, we are going to create or mention all these steps in one single file, and then we will call it as our image, so that we don't have to repeat the same thing again and again. The same thing now all the restaurant chains are also doing. I'm not aware if you guys are aware. Nowadays, if you go into any of the restaurant and if you order a food, they don't cook the food from beginning. What they do, they already have the recipe, they already build that particular food item, and then they make it airtight. Okay, they make it airtight means they just build the entire recipe. I don't know exact technical name over here, but they build the entire recipe. They put it airtight. They put it in a cool temperature. Now what they do, they supply this particular food item to all of their hotel chains. What this hotel chain does, whenever you will do an order, they just have to heat this particular package which they have created. You just have to open this package because it will be in a very low temperature. They are doing it for a better life cycle of this particular food item, so it will not expire. They will share this particular package, okay, to all of their hotel chains. What they will do, they will just heat this particular food item or this particular package, and your entire, let's say, paneer or whatever will be ready in a minute, in few minutes. Okay, everyone is using these days. It's not good for our health, but companies are using it. Why companies are using it? Because they want to give you fast service. So they are going to create this recipe pre-handy. Okay. If you will see any of the startup idea these days, they are going to do the same thing. Okay. They will create their recipe. Okay. They will create their recipe at one place, and then they will package everything, whatever is required for that particular food item. And then once they will package everything for that particular food item, then they are going to just heat it, and that food item will be ready. Exact same thing we are doing in Docker as well. We are creating the entire recipe for our application, for our server. This is nothing, it is just a recipe we are creating for our server. Like for our server, I need a Python interpreter, I need a code. Everything I will put, then I will put this image file at a centralized location. Anyone wanted to run this application, they will just download this image, run a container from this image, and that's it. It will be ready in front of you. Okay. So it was a very basic example just to explain you why this Docker is so fast. So they are creating this recipe for your Python server, your whatever server you are creating, pre-handy. Okay. Beforehand, they are creating it. And then we are just running it. We are not doing this or repeating the same steps again and again. Okay. So guys, I have one image with me, which I'm going to show you now. So I hope you guys would have played Mario game in your childhood. So if you go back to my repository, I have one repository for Mario game. So now I'm going to show you how can you create your custom images, custom recipe, custom package. Because till now I was going to Docker Hub, and from Docker Hub I was downloading some of the pre-created image. But now I am going to create my custom image. Okay, and if you wanted to create your custom image, you will have to create one Docker file. Okay, Dockerfile is one of the script, you can say, where you will define all your instruction. So all the instruction for building one image will be defined in Dockerfile. And once you have defined everything in this particular file, you can build it. You can build the image from it, and then you can further use this image for running your application. Okay, so if you also wanted to create a custom image, it's very simple. Okay, before showing you this practical, let me just show you how it can be done. I'm going to create one file. Normally the file name will be D, will be capital, and then Docker file. Docker file. Now in this Docker file, now I'm going to define how my image will look like. Okay, the image for my application. How will it look like? So I will say whatever image I want. The first instruction which I will mention, like there are multiple instructions you have to mention. If you go back to the documentation as well for Docker file, okay, Docker file instructions. So you will see all the instructions which are available in the Docker file. One of the instructions is from. From means, do you wanted to create this image from beginning? Okay, or you wanted to take something as a base image, and in top of that base image you wanted to perform your further custom configuration. So in my case, what I will do, I will take, let's say, I will use the from instruction, and I will take, let's say, Amazon Linux as one of the base image. Okay, In top of my Amazon Linux image, now I will put here my custom files, my custom data, okay, my custom steps for running my application. Okay, let's talk about a Python application. So if you wanted to run a Python application, it's very simple for you. You can use either the Amazon Linux as one of the base image, or we have some of the Python base image also available. Let me use Amazon Linux. After taking this as a base image, what next we have to do? We have to install Python. Okay, we have to install Python. But I don't want to install this Python while the runtime. Whenever I will run a container from this image, at that point of time, if I install the Python, it's going to take time. So I want everything to be handy with me. That's why while building this image, I'm going to install Python over here. And if you wanted to run anything while building, we have a run instruction for that. It will execute command within the container build environment. So here I'm going to use run instruction. Okay, for our Python application, what is the first step? The first step would be yum, can you please install Python 3 for me? And then I can use here hyphen y. Hyphen y means whenever you install a package, it will always ask you for yes or no. It will ask you for a confirmation with, do you want to install this package? Hyphen y means yes, I'm giving yes, I want to install this package. So don't ask me for yes or no every time. Once you have Python installed, what will be the next step? Again, I'm going to use one more run instruction, let's say. Once my Python is installed, the second thing is I'm going to install pip3. That is my Python package manager. Okay, how to do that? I will say yum install. There was a package called as Python 3-pip. And again, I will say -y. So my pip3 will be installed. Once your pip3 installed, what next you will do? Although, guys, you can put all this thing in a single line as well. Make it simple. I'm giving it multiple lines. Third step will be once my pip is also installed, pip3 is installed, that is your Python package manager. Same setup, guys, we did last time manually, but now we will do it in a better way. Okay. The third step which we have to follow, okay, I forget where I added, is we have to install our Python dependencies. So where my Python dependencies are present, so I will have a requirement.txt file. That requirement.txt file has all my dependencies installed. So I will have to mention here that can I do pip3 install -r requirements.txt. But right now in this particular image, I haven't copied my source code. My source code is not copied over here. Okay. So first of all, I will also have to mention that I wanted to copy my source code. I will say all the source code currently I have in a particular directory. Okay. Or you can say dot means whatever source code will be present in my current directory, okay, will or should get copied inside my container image. Okay, I say dot over here as well. It means everything which will be present in my file system will be copied inside my container. So if I save this file till here, so whatever is present at this particular location, it will be copied. It will be copied in my Docker as well, Docker image as well. Okay. Or I can say I have sample Flask app application. I wanna copy everything inside sample Flask application. That also you can do. Okay. Or let me do one thing. Let me move this Docker file from this location and let me put it in the correct location. So it will be better for us to manage it. Sample. So we have a command. The command is mv command. Mv command is useful for moving a file from one location to another location. Last time my Docker file was present in this location. Now this Docker file is present in my sample Flask app location. You can see ls. So what I will say in my Docker file, I want to copy every file which I have it over here inside my Docker image which I'm going to build. That's the reason in the beginning I use one copy instruction. Copy instruction means it will copy everything which is present right now over here to my Docker image. Okay, same thing you will see over here. The copy will be there. Copy files in directories from your host machine to your container image. Okay. Once your images are being copied, you will install Python. You will install let's say pip3. You will do the requirement.txt. And once everything is being done, now what the final thing you are going to do? Okay. The final thing is you will start your server. Okay. To start my server, what is the command? Command is Python 3 space app.py. This is going to start my Python server. Okay. But I don't want to start my Python server at this particular time because I'm just building my Docker image. I'm not running my Docker image. When I will run my Docker image, at the runtime, I want this server to be started. at the build time, like whatever you mentioned in the run instruction, it will be applicable only at your build time when you're building your image. Okay. But this command I don't want to execute right now while building my image. This command I want to execute while the runtime, when someone will create a container from an image. For example, when I was creating any of the container till now, so you can see they were running some kind of command, bin bash. As I started this container, they have executed bin bash command. This one have executed some nginx command. This one also have executed some nginx command. In our case, when someone will run my container from this particular image, what command do you want it to run? So here I want this command to be run. So here I will not use run instruction. I will use a different instruction. Okay. So here you can use either the CMD or the enter point. There's a small difference between CMD or enter point. We'll discuss about it. Let's say right now I will mention that I wanted to use CMD instruction. Okay. So I'll say I wanted to use, sorry, what happened? I think my code is now removed, CMD instruction. Okay. So I'll say Python 3 and then I will have, okay, app.py. So what this will do, this will start my Python server. And because I am the one who has developed this Python code, so I will know in which particular port number it is going to be running. Okay. So I can also mention one more instruction over here. Okay. There will be one instruction called as expose instruction. This will specify the port that the container will listen on. In my case, I'm running a Flask server and my Flask server is listening on port number 500. So I will have to mention, I will go back to expose section. Okay. And then I will mention that my container is going to listen on port number 500. What will happen now? Okay. So I have defined everything which is required for my Docker container to work. Everything which is required for my Python application to work, I have documented over here itself so that I don't have to repeat this process again and again. Okay, this process will be automatically managed. Okay, so now let me save this file. If you wanted to create, okay, if you wanted to create one Docker image from this file, this is just an instruction which we have created. Okay, so what you can do, you can use Docker build command. Okay, Docker build command. Then you can define your image name. What exactly image you want to use over here. So what name you want to give to your image. You can give any random image and any random name. So let's say I will give a name GFG image. And then you can give a tag to your image as well. Let's say the tag is V1 tag. First version of the image I'm creating. So that is a tag we are giving over here. Okay. Now what next we will do? We'll use press space and then we'll press dot. When we press dot, what means they will find my Docker file at my current location. Dot means please find my Docker file at my current location. And my Docker file has all the instruction. So right now I'm preparing my image. This is a command to prepare my image, create my image. And while preparing my image, I have defined all the steps which should be present. So you can see while building the image itself, all these commands are getting executed so that when I will try to run my application, then these commands will not again get executed. So within the build time, I am doing that. And you can see my image is created, saying image is finished. If I use Docker images, so now they will show me one more image that is called GFG image. This is an image which I have created. Till now, we were using some of the image created by someone else, but this is our custom image which we have created for our use case. Okay, GFG image in this case. Okay. Now, if we wanted to run a container from this image, okay. So how can we run? Again, the same command, Docker. You can use Docker run. You can run in detached mode, DIT. You can give some name as well, my web OS. Okay. And then you can give your image name. Image name is GFG image. Okay. GFG image and your server will be started. Okay. As you will do this, okay. Sorry. Now you can see there's a problem. I give my image name, okay, and they were not able to find this image locally. Why? Because I haven't given a tag over here. If you don't give any tag, by default, they will look for latest tag. But the image which I have built, they have a tag V1, not latest. So I will have to give the exact thing V1 over here. And you can see my image is ready. Just as I will click, my container will start. And you can see my container is right now will be in running state, Docker PS. If everything goes well, you can see my container is now right now in running state. Okay. from last 5 seconds. And my container is running a command that is python app.py command means they are running my Python server. If I get to know my container IP address, then I can connect it to this container IP address at port number 500 and I will be able to see my data. Okay. Or if you wanted to connect to this container from outside world as well, so you will have to do the port mapping for that, as we discussed. So while launching your container, you will have to also define one more option -p. Let's say you can say anyone who will come to port number 8080 in my to my base system, they will be mapped with port number 500 because in port number 500 my Flask server is running in this case. Okay, so we are doing a port mapping over here. Now you can give a different name to your container. Your container must have a unique name. Now if I do Docker PS, so you can see one more container has been launched within a second. Both the containers are running the same application. So image you have to create one time. From that image you can create containers hundreds of times. Okay. Now this container I have exposed as well. I am saying anyone who will come to port number 8080 of my base system, they will be mapped, they will vent or they will connect to my container. In my container, there is a program running at port number 500. In 500, my Flask server is running. So what you need to do, again, go back to your security group and allow port number 8080 from the security group rules. I will just click on edit inbound rule. Okay. And add rule. Okay. And just allow port number 8080. I will say anyone from this, anyone over here would like to connect, they can do that. I will click on save rules. And you can see it is created. It means if I again copy my IP address and if I hit to port number 8080, okay, so okay, they are again showing me my application. The last time when I created my application, that was a manual way. I was doing everything on my virtual machine manually, but this time I created one Docker image, and from Docker image I am doing it. And this Docker image creation is only a one-time job. Once I have this Docker image, now I can share this Docker image with you guys as well. And you can also pull my image. And just after pulling the image, you can also launch same kind of server. Okay. So if you wanted to push this image to your Docker hub so that your other people, other consumers, other colleagues can also use it, you must have an account in Docker hub to utilize it. So if I go back to my Docker hub, I must have an account. Right now, I already have an account. Otherwise, you can go to Docker hub. Okay, you can click on account settings or you can create one account for yourself. Okay, you can create your account. It's very simple. They will just ask you for an email address or some basic information and your account will be ready. In my case, some testing account with this name is created. So I'm going to use it. So I'm going back to my local system. I will have to first authenticate to my account, first log into my account. And for that, we have a command Docker login command. Okay. Means I'm going to log in to my Docker hub account. Why? Because I wanted to push some of the images which I have built in my this particular system over there. Okay. So I'm saying Docker login. They will ask me my username. I will give my username. And then they will ask me my Docker hub password. Okay. So let me type my password. I have written my password. And if my password is correct, you can see login is being succeeded. Login is succeeded means now I can push the image to Docker hub as well. I have logged into my Docker hub account. If you want to push any of your image which you have built locally to your Docker hub, you will have to first re-tag your image with your what we say account name. So in my case, account name is this one. So I will have to tag my image with this particular name. Okay. For that we have a command, Docker tag command. And as a Docker, I have an image whose name is GFG image version is V1. I want to re-tag this image. Okay. And I want to re-tag it something like my account name, and then I can give any name. Let's say GFG sample image. What will happen? Now there will be one more image created, okay, with a newer name. It is something like you are renaming your image. You are just changing your image name. So whenever you want to push image to Docker Hub, you will have to rename it as per your account name. My account name was this. So I have changed it as per that account name. Now I can use Docker push command. Till now I was using pull command because I was pulling the image from Docker Hub to my local system. Now I am pushing the image from my local system to Docker Hub. So I will use Docker push command. I will copy my image name which I have created. Okay. And then I will run this command. What will happen? My image will get pushed to my Docker Hub. Once it is being pushed to Docker Hub, you guys will also be able to pull it and you will also be able to run it. Okay. So in a minute, it will be pushed. Meanwhile, this is getting pushed. I have one more Docker image handy. Okay, that will help you to play Mario kind of game. So if you see in my repository, I have one more repository called as Mario game. So what I did over here, I had a code. I found this code on the internet for Mario game. Someone has created a Mario game code in JavaScript so that you can have a Mario game kind of interface like this interface, okay, and you can play it in your browser itself. So the entire code for this Mario game is written in your HTML, CSS, and JavaScript. You can go to this Mario game folder, and here you will be able to find out all the source code, all the JavaScript source code. If you are aware about JavaScript source code, you can make the modification as well. But let's say I found this code. Now what I want from this particular code, I wanted to deploy one of my application. Okay, so I'm just giving you my repository URL over here. Okay, so first of all, I will have to build a Docker image. So you can see here I have a Docker file as well. If I open this Docker file, okay, so in this Docker file, I have already mentioned how my image will look like. So I mentioned that we are going to take Nginx as one of the base image. Then in this base image, I'm going to copy my entire source code with the copy instruction. Then I am saying that my server will be running on port number 80. And then the last thing with the CMD command, we are saying, please start my Nginx program. This is a command to start your Nginx program. That's it. If you will run this particular Docker build command, then your image will be built, and this image will be running your Mario game application. So what I did, I built this particular image and I pushed this image to my Docker hub. Okay, and now I'm going to use it. Meanwhile, this image is also being pushed. So if I go back to my Docker hub, okay, and my hub, okay, so if I go to my hub over here, so they will show me, you can see this image was just pushed 2 minutes back, which I have created. So if you guys wanted to use, you can come to my Docker hub account. Okay, let me click on public preview. So you can come to this particular link over here. You can also pull this image and the same kind of Python application you will be able to see. Okay, this is a URL I have given. Now, similarly, I have one more image present in my Docker hub that is for your, okay, that is for your Mario game. So you're gonna play this. I will just go to Mario game, sorry, my hub. I will search for it. You game. This is the image which I'm going to use. Okay, let me click on public view. So you guys can also use it. This is a command Docker pull, and then this is my account name, and then the image name is also there. So let me give it to you. This is a so I will go back to my system, and from my system, what I will do, I will pull this image. Okay, and after pulling this image, I am going to create one container from this image, and you will see in that container the entire game will be running, which anyone can play. Okay, so the only thing is I have to pull this image. If this image has the entire source code and everything this image has. Okay, now I'm going to say Docker, do you have this image installed? They are saying yes, we have the image present right now. I will say Docker, I wanted to launch a container from this particular image. Okay, in my detached mode, and then I will say, or let me run in foreground itself. I will say I want to do a port mapping as well. I will say anyone who will come to port number 9090 of my base system will be mapped with port number 80 of my container, because in port number 80 of my container, my server is running. And then I will give my image name. My image name is this one. I will paste it. Let me copy this once again. And that's it. My server has started. Okay. You can see server has started right now. Sorry, I used the wrong image, not this one. I wanted to use this image, right? Mario game. Sorry. Mario game. This image I wanted to use. Let me just select some other port number 9091, for example. As I will hit, my Mario game will be ready. So I just have to go back to my security group to allow one more port number. Okay. And that will be 9091. 9091. And then I will allow it for everyone. Save these rules. If I go back to my application, now in my application, there are so many services running, right? Let me copy my IP address and let me go back here at port number 9091. So you will see the entire Mario game will be reloaded. So this Mario game is again running in a containerized application in the container. In the container it is running. So in the container, we already had the source code. I have already built the everything like whatever is required, and you can play also. Like you can move it or you can do it. If you don't do it, okay, so this is a normal game anyone can play, but this is running in a containerized environment. So whatever application you create, I get a simple Flask application that is also running in a containerized environment. This game is also running in a containerized environment. Similarly, in tomorrow's class, we are going to create some node kind of application maybe. So that will also be running in a containerized environment over here. Okay. So guys, we took some extra time, I think, in Docker. Okay. So we didn't have much time to start Jenkins. So what do you think? Should I start Jenkins as well? Like I'm free. I can start Jenkins right now as well. So, sir, you are saying you have multiple instances of particular application. Then how can I map the port to particular instance? Yes. So you will have to do. Okay. So you are saying that, and what about the load balancing between those multiple instances? So load balancing will take place. Again, we don't have time for discussing the load balancing. The only thing, guys, is if you remember the last practical, this one, I was saying that we are going to create multiple virtual machines. Why are we creating it? Because in multiple virtual machines, I am creating it so that I can distribute my load. How will I distribute my load? In each of these virtual machine, my application is running. And each of these virtual machine will have their own IP address. Okay, each virtual machine will have their own IP address, and maybe in different port number my application is running. So my consumer can't remember these many IP address or these many port number. So I will have to give only a static DNS name or a static IP address to my consumer. Otherwise, my consumer will get confused because these virtual machines will keep on getting created dynamically. More and more virtual machines I can create, and more application in that virtual machines I can run, and they might be running in different port number. That's why here we will need a reverse proxy or you will need a load balancer. What load balancer will do? So load balancer will work like a mediator in between your client and your servers. So my client will connect to a load balancer. Okay. In load balancer configuration file, we will give the information about all the virtual machines which are running, or all my servers which are running behind the scene. Okay. All of them will be connected to my load balancer. Now, these servers will have their own IP address and port, which you don't have to worry. In the load balancer configuration file, you can mention that this virtual machine IP address is currently mapped with, let's say in this application, here we are running an application at port number 80. So you can say 80. This virtual machine IP address is IP address 1. Here it is running at port number 82. Every entire mapping you can give to load balancer, and your client is not going to connect with your virtual machines directly. Your client is going to make request to your load balancer, and load balancer is going to give him a static IP address or static DNS name. And this IP address and port number, my load balancer is going to, my client is going to remember. So my client is going to hit to my load balancer. My load balancer is further going to distribute the traffic as per their availability. If I launch a new virtual machine, as per the scaling, I have more load. Automatically, this new virtual machine will also get attached to my load balancer. So load balancer will work like an intermediate, and load balancer we will use everywhere. So once I will show you Kubernetes in tomorrow's class, there also you will see we will be creating a load balancer to distribute all the traffics. Okay. So, so guys, anything you want, like I have experience of teaching continuously for 8 hours as well. Okay. Without eating waters, without drinking water, I will say, or without eating anything. So if you want, I can teach till the night as well. It's fine for me. Okay. So if you want, otherwise we can obviously resume in tomorrow's class about Jenkins. So what do you say? Thanks, guys. Okay, not today. I can see a lot of people are saying not today. Okay, so let's pick Jenkins tomorrow. Actually, guys, the problem is we have very limited time. We have just 9 hours, and I have so many things to explain to you. So let's do one thing. Let's start Jenkins tomorrow as well as Kubernetes tomorrow, and then the practical which I discussed. So whatever practical, the final goal of this workshop was that I will show you a full stack application. We will be deploying that full stack application via CI/CD pipeline in a Kubernetes cluster, which will be running in AWS cloud. So in that practical, again, Docker will be revised. Again, virtual machines will be revised. Again, all the cloud computing knowledge will be revised. And tomorrow, again, we will have to learn about CI/CD pipeline. So currently, we discuss about CI/CD pipeline in a theoretical way, but tomorrow we'll see it practical way in that case. Okay, and we will complete our practical or agenda. Okay. Anyone have any queries you can ask me? Okay, Sarath, again the same thing. I think I have explained it, right? So you're saying what is the difference between what is the advantage of using Docker or running your instance in different code? Yes, you can run your instance in different code. So this is your operating system. In this operating system, you can run multiple applications in different code. But the problem is, how will you take care of security of this application? Let's say here you are running application number one, and here you are running application number one, two. If your application number one is, let's say, being hacked by someone, how will you take care of security of the application number two? For that, you must have the knowledge of your operating system, and you will have to make each one of them secure. You will have to make them isolated. Otherwise, how will you secure them? How will you give each one of them their own file system to work? Okay. How will you now add here a limitation that this application will be able to use only let's say 1 GB of RAM at max? This application has more priority. This will be able to use 30 GB of RAM at max. How will you take care of it? Okay. So doing these things on a normal operating system can be done because your Docker is doing nothing. Docker is behind the scene using the features of your Linux kernel. These features you can directly use as well without Docker. But for that, you should have a good knowledge of Linux kernel, and a lot of settings you will have to do by yourself. And this will make entire setup very confusing and very uh, problematic for you, because now whatever application you are creating, you have to take care about their security, who can access them, okay, their file system, their storage, as well as their isolation, as I discussed. Okay, maintaining these things manually can be done. It's possible, you can do it. Okay, usually in my Linux class, I show it how we can do it. Okay, but it makes the process very very hard. Okay, but Docker, in the second hand, Docker makes you or give you these things by default. So you don't have to do any such configuration at your end. Docker give you all these things by themselves. By okay, or even if you wanted to add some further customization, Docker have options for that. So these entire setup can be easily managed via Docker. That's why we are using Docker. And the third reason is, whenever you deploy your application directly on your operating system, you are deploying this application manually. Entire configuration of this application, installation of this application, okay, execution of this application, everything you are doing manually. But in case of Docker, you can just create one image, that is a one-time process. From that image, you can launch multiple replica, multiple copy of that application within a second. That is also one of the benefit we will use Docker. So yes, anyway, you can do the same setup in your operating system directly. You can launch multiple programs at different port number. Okay, but with Docker, this entire setup will be very easy, because in production environment, we also have to consider about security, isolation, all these things we have to take care of. So doing it by yourself will be a very time consuming task. Okay, so guys, anything else anyone have to ask? Right now, I'm checking my Zoom chat only, not in YouTube. So YouTube, I may check later. Okay, so for that, we have a hyphen memory option, Saraj. You can just use hyphen memory option for your setting up the RAM. For CPU also, you can decide which of your container will have more priority. That is called a CPU scheduling. So you can do the time scheduling as well. For that, you will need to have some knowledge of Linux kernel. So guys, if you want to know this information in much detail, so that you can reach out to me. I will give you some of my documentation, some of my lectures where you will be able to understand it. In this training, it's not possible to cover, but in some other training, I will be able to. So laptop, Prashant, like any laptop you can use. You can use virtual machine, virtual box you can use to launch your Linux operating system. Like right now I'm in Windows. In top of Windows, if I have to launch my Linux operating system, I can use virtual box. Via virtual box, with the help of virtualization technology, I can launch my Linux operating system. Okay, for that also, I have in my repository, I have added one document, PDF document, rel9 installation in Windows. You can follow that. Okay, I'm again sharing this repository link on Zoom. I will share this repository link in my YouTube chat as well in some time. Okay, so you can connect with me on LinkedIn. That is, I think, only way available. So connect to me on LinkedIn if you wanted to have some or wanted to get more knowledge on any specific topic. Okay. Multiple image can be accessed in a single web server. multiple image. Yes, like here you can see I have one server. If I go back to my EC2 instance, which I am running, in this EC2 instance, you can see right now I'm running so many programs, so many images are there. I have installed the downloaded the image for Ubuntu as well. Let me just close this one. Docker, PS. Because so many containers are running. Each of these containers are from different image. This one is from different image. This one is from different image. This one is from different image. You can do that. So we can launch multiple containers from different kind of images in a single server. So like I had one virtual machine. In this virtual machine, I am running so many containers, and each container is from some specific image. Okay, guys, is anything else you want to discuss? Any other doubts you have? Okay, guys, then I will consider that's all for today. I know we took some extra time. Okay, but that's all from my end for today. Have a good night, and we'll meet tomorrow with a new practical, okay, for deploying a full stack application on a EKS cluster. Okay. Please, guys, practice all these things. I will update my repository with the updated resources. So by tomorrow morning, I will update my uh, GitHub resources. So you can take those resources and you can practice. Okay. That's all, guys, and from my end. And thank you for your time. Bye.